the relevant parameter for the electrical infrastructure, right? So
Yeah.
till now, if I look at what we have gone through, understanding of the electric vehicle first, right? Their
Yes.
parts, then their working principles, major components,
Yeah.
efficiency differentiation, right?
Yeah.
That part we have to now address. From today, let's say for today's session, we are going to cover the comparative study in more deeper one. Okay,
Yeah.
because this is enhancing your base foundation, and we can directly correlate with the understandings related to the charging.
Yeah. Sure.
So if I look at the IC engine, so whereas I'm saying wherever I'm saying IC means internal combustion engines, okay, which is the current your what I can the gasoline engines basically, right?
Yeah.
So IC engine, if you compare with EVs, what is their benefits and then what is the challenges? If you
No.
compare electric vehicle versus IC engine vehicle, what all those benefits they have and then challenges we need to face.
You mean benefit of using EV charging and compare with IC engine, right?
Yes, yes. EV charging vehicles, respective vehicles we are speaking of.
Yeah. Mainly, the first benefit is from fuel consumption perspective. We don't need anymore any fuel, and this contribute to solve the problem of global warming.
Okay.
Yeah. The second part is using EV. I think it's less in maintenance and higher in efficiency, as we discussed previously. Okay, which is adding a point to the EV. Also, as benefits, I think it's something related to safety. If we compare it, both component of IC engine and compare with EV, I know EV is still in development stage, and safety still in progress. We can say that in development, but I think the safety is higher in EV in compare with the mechanism of IC engine and the theory of operation of it. Challenges, of course, there is a lot of challenges for EV charging. The first, the lack of charging stations. I think in most of the countries, even the countries who implement the EV, still having a problem with the number of EV charging station and the time consumed to charge your car. This will take a bit time. So if you are driving 300 kilometers and you need to wait in between around 40 minutes to charge, this is a lot for a human behavior.
Right.
The second is infrastructure itself, the associated infrastructure. It's not similar to the normal infrastructure for electrical grid. It costs more due to the demanding, and somehow it's challenges, and they come up with some management software which can mitigate this little bit, first in, first out, or charging at the same time for the vehicle. But still, infrastructure have it's a big challenge in terms of cost and the impact on the overall economy in general. The challenge is also in terms of impact on the grid itself, since if we are using DC in some cases, this will have harmonic issues. And these harmonic issues mean we need to mitigate this harmonic somehow. Of course, we need to simulate it, and then mitigating is a harmonic impact. The challenge is also in terms of safety, because if the temperature is high, then battery should be housing in proper housing, so in proper frame, so we can dealing with cases of increasing of temperatures. And of course, DC charging, which is quite fast in terms of high temperature. And of course, the EV, you can depend on it within your city. For instance, you cannot depend on it in long run destination. I think this will require the stations. It will require somehow bigger capacity of battery. There's a lot of things. Yeah, I think this is from my point of view.
Yes, absolutely. You are on the correct track, and you are observing the same results, which industries right now facing as a challenge, and putting the words like whoever is in the sales team, that are putting the benefits of the part, right? So the points which you address, the part related to global warming, increase in the heat on the Earth surface, right?
Yeah,
And let's say reductions in the availability of the fossil fuels, right?
yeah,
And utilization of, let's say, the what I can say, the sun electricity, right? The solar power
yeah,
is more good part to make the planet happier, as well as, let's say, the
yeah,
convenient way to live in the life, right?
yes,
Second part, with respect to the challenges, about, let's say, very specific part you told, the battery case and all. So if I observe in the third person perspective, the battery specifications and those parts should be taken care by the battery manufacturer as well as the EV supplier, right?
yes,
So
mm,
being in, let's say, a integrator, a person who is integrating, a person who is enabling the EV charging, we really need to understand the pain areas in the battery as well. But on a practical approach, basically that won't be the scope of work for us, right? That is a
yeah,
part of vehicle, and that will be taken care by the manufacturer of the battery as well as the manufacturer of the vehicle itself.
yeah,
We mostly deal with the compatibility of your charger of the battery
yeah,
and the grid path, correct?
yeah, sure.
So as far as looking for the grid stability, again, when a government, when a public sector entity is trying to do something, modifications in existing infra, they need to take care of rest of other part, right? Even, right, obviously, yes, like we are converting AC to DC, right? And that
Yeah,
device is called as a charger. Whoever is converting that AC power into DC to get charged your vehicles. So
yeah,
only within that charger, the harmonics needs to be controlled by you. I mean, not you, like that device should control, or you should design that device in a such a way that there will be a minimum harmonics.
yes,
And on the grid side, the grid authorities will take care of that part. Even if, let's say, that devices, see, there will be like authorizer party, right? Authorization party, they will approve your charger, whether it's okay to put into the grid or not, correct?
yeah. But is the one who should study the impact on the grid?
Yes.
Is this should be by us or should be by the government, for instance?
Depending upon the policies of the states and city, what they are applied.
Okay.
In India, what happens, any charger comes to the market, they need to get approval from the government authorities first, and then only they will get the permission to sell that charger into the market. So
Yeah,
what they are testing the feasibility, whether it will be matching the, let's say, the frequency of Indian infra or not, whether it will be compatible to our existing infra or not, right? Is there any cross impact within our system or not? They will cross examine at the unit level, and
yeah.
then only they will grant the permission. You should go to the market and sell your product in India.
Yeah, because
Obviously,
it's at unit level.
yes,
At
it
unit
is
level.
unit level. Second part, on, let's say, you are setting up a large fleet, okay, on a single point.
Okay.
Then and you got the approved, let's say, chargers in place, but in still in that scenario also, let's say you are putting a new project whereas a large fleet is there, you need to construct the single line diagram of your network, you need to provide the calculations, whatever you did with, right? And you need to submit with the local government authorities, the network maintaining team, who's ever in the local areas, right? We need to submit that, and these people will again validate our network, our calculations, and based upon everything, they will guide to, let's say, change something if needed, right? Or they will giving us this is the okay, and you can go ahead with that. So
And
that
these
way,
calculations, I know it's part of this course. Is it something complicated or?
these calculations are not a part of course, correct? But I have covered some portions of that within the calculations. So you can, like, you will get the exposure for the same.
I think in
Because
chapter 6, 5, and 6 is risk calculation, right? Sizing
yes,
of.
yes, depends upon the, because see, if you are putting a single device, or if you are putting a 10 devices, or if you are putting the 100 devices in a single place, right?
Yeah.
That differs to the infrastructure and then backend calculations. Everything matters on that.
Yeah. Yeah. Okay. Okay. Clear.
And obviously, yes, it's let's say you need to get the local authorities approval to put your system on ground.
Yeah. Clear. Clear.
Yeah. Now the benefits part, we will just summarize. As you said, like there is no gas and hydrocarbon fuel is required, less operational cost, right? The maintenance and operations part is less.
Zero.
There is zero emission, there is noise-free devices, right? As compared to your IC engine.
True. Yeah, I missed this point.
And there is a low maintenance comparatively, and it is more efficient than IC engine. In terms of, let's say, challenges, range and anxiety. As you said,
What is
like,
that?
like 300, 400 kilometers is a single charge, and then you need to wait for charging time, right? That would be inconvenient for the user behavior.
Yes.
So that is a range and anxiety. Like in gasoline, what we have right now, the habitual part is we are going to the fuel stations and it will be getting filled within the, let's say, 2-3 minutes, right? And then you are again on track to your journey. But in EVs, that is quite complex right now for larger vehicles. But if I compare, let's say, for the two-wheelers or the cycling part, okay, and even some three-wheelers also, there is a battery swapping option. Okay. Have you seen the torch which is operating on the charging cells?
No. Can you repeat again the questions?
The torch, the small torch, like toy torch, you can say.
Yes.
Cells, right? And what we are doing, basically, if that cell is dead, we are replacing with the new one.
Yeah, it's clear.
Right? So similar approach in the two-wheelers also. There is a battery containers coming right now. Okay. You need to just go to the fuel station, like similar to the fuel station. There is a battery swapping station. You need to put your battery, draw out the new one, like which is charged one, right? And put into your vehicle and just track to road.
Yeah, but this is now implemented?
It is implemented.
But it's a weird solution a little bit because this will cost me a lot. Or what do you think?
The business model is here. It's a different, like there is a third party comes into the picture, like a service provider who is taking care of those batteries. They will be owner of the battery. You need to, let's say, buy their subscription, correct? Let's say a normal amount, like if I compare with the Indian cost, that will be charge you yearly, let's say 1,000 rupees or 2,000 rupees for a, like what we can say, the guarantee amount. Okay. And later on, you will get, let's say, a single charge of 30 rupees, 40 rupees of charge to your batteries. And that will be readily available. You just need to remove your battery, which is dead right now. Go to the charging swapping station, place at their premises, okay, and draw out the new one, which is charged, right, and put into your vehicle and just move to the road.
Okay,
and
clear.
This quick action is, let's say, hardly taking your 4-5 minutes. Similar with your fueling to your two-wheelers within the gasoline.
Yeah. Clear.
But
Yeah.
it is now it is implemented only for the metro cities. Okay, and these are very few right now because it is operated in the very controlled range. It can't go for like 300, 400, 500 kilometers.
Okay. Okay.
Second part, what we need to challenging on the ground is your lack of charging infrastructure, right? It
Yeah.
is,
Sure.
if I compare the countries like India, it is growing, but not up to that much level. It is still, there is a area to enhance, there is an area to improve, right? Put the
Yeah.
more
Sure.
charging infra as well. Then if you look at the cost wise, the initial capital, right? When person is buying the gasoline vehicle and person is buying the electric vehicle, there is a huge difference in the cost. So EV is, let's say, more costlier than the ICE engine, the capital investment. So that is again a point where we need to look into as a challenge. Then second part is very important, like lack of assurance to resale for satisfactory value.
Okay. Yeah.
Right, because people are, because this is a new technology, people are worried about it. If I buy the vehicle after 10 years, can I sell this? Or will it be
Yeah.
feasible? Right? What would be the return cost to me? Right? So that assurance within the people is not there right now.
Yeah.
Nobody is
Clear.
assured because technology is new and it is
Yeah.
evolving. After
Yeah.
5
People
years,
worried. Yeah.
yes, after 5 years, we don't know the same technology will be available or vanish.
Yeah.
Right. So
Yeah.
that's what the area where, let's say, industry needs to think and build such a devices, such a products, so that it will be have a definite value after, let's say, resale as well. Like for gasoline vehicles, they know, like, because it's a matured technology, right? ICE engine is matured one. We know if we buy it today, after let's say 3, 4 years, there is some value I will get it.
Yeah.
But
Clear.
what about the EV? I don't know, right? So
Yes. True.
that's what the part. These are the like challenges we need to focus upon in improvising, let's say, vehicle part. Again, the challenges part is, as you said, like on an infrastructure, but mostly that will be taken care by the infra authorities.
Yeah. Clear.
Okay, clear?
Yeah.
All right. So we will see the vehicles classification now.
Okay.
Electric vehicles, there has been different type of vehicles in the market, right? But what is most common and what is most popular is, in terms of EV, this one,
BEV. Battery
BEV,
electric.
battery
Yeah.
electric vehicle.
Okay.
Your this part, like a battery, a plug-in hybrid electric vehicle, if you observe their architecture, you will get the realization what is the core difference in it. Like battery electric vehicle, there is a battery, electric motor, and then recharging, regenerative braking part, like your what we can say transmission system. Okay,
Yeah.
this part. So battery, motor, and transmission system for
Yes.
BEV. If you look at the plug-in hybrid electric vehicle, there is a fuel tank also.
Yeah.
There is a battery also. There is a motor, and then there is system.
Yeah. And how I can decide which one I should go with?
Yes, there is a switch. Like priority is always for the battery. If battery downs, then you can shift your vehicle on the gasoline, right? And then gasoline will power to your this device, like transmission systems.
I think in terms of cost, which one is higher?
Obviously, it is because two different sort of engines it is working, right? So there is motor, there is ICE engine. So obviously it is charge you more.
Yeah, clear. Okay.
Then there is hybrid electric vehicle. Okay. So in hybrid electric vehicle, what is happening? If you see, there is again similar approach. What is change in it?
Yeah,
In
it's a built-in
HEV and
charging.
PHEV. Yes,
I think it's
so
built-in charging from ICE movement. Yeah.
correct.
Mm.
Exactly. There is no here. It's a charging point. There is no charging point,
Yeah.
right?
Yeah.
So it's an inbuilt battery is getting charged. Initially, it will operate on the IC. Okay, IC will power to your vehicle as well as it is getting charged to your battery.
Battery. Yeah.
As soon as your IC gets down, your battery will power to your requirement.
Yeah. This is less in cost in comparison with plug-in hybrid.
As comparatively lesser, but it is again costlier than this one because
Yeah,
there is
sure.
also two engines.
Yeah.
Then there is a fourth one like FCEV, fuel cell electric vehicle.
We'll sell electric vehicle.
Fuel cell electric vehicle,
Yeah.
right? What is it? Like hydrogen fuel cell? They have the hydrogen fuel cell.
Yeah. What is the
There is
fear of operation here?
hydrogen fuel cell. There is catalytic analyzer. Like mostly people are saying catalyst inverter. Okay. So what the principle is like pressurized hydrogen is available in the container, pressurized oxygen in the available container. They will pass through one catalyzer, okay, and catalyzer will produce overflow of electron. That is a flow of electricity, right? And that electricity will bring to your charging the motor, charging the batteries, and then battery will power to your motor, and it will
Oh.
generate the movement of the vehicle.
So mainly you need to fill the tank with hydrogen.
Yes, you need to fill
Then
the tank with the hydrogen.
then this hydrogen will how I can say it?
So it's a purely different technology. Okay. Now the vehicles are in the market also with the hydrogen fuel cell. The vehicle like the common name people are treating for this FCV is hydrogen vehicle or maybe hydrogen fuel cell vehicle. Okay.
Okay.
And
But this is okay.
uh, give me a moment. And it is, let's say, the emission of this vehicle is your pure water, H2O. Like IC engine emits your hydrocarbons, right?
Yes. Yes.
But this FCV will emits the H2O, water itself.
Oh, okay. Okay. So
Yeah, so it's
after
a
the
purely
process,
zero emission vehicle.
yeah, and the emission is just water.
Yes,
H2O.
emission is just water.
Okay. Okay. Clear. Clear.
So that will be again putting a huge benefit to the environment.
Yeah. Sure.
And now in the market, let's say in upcoming time, this BEV and FCEV will compete with each other.
Yeah, because of maybe it's near in term of cost.
Yes, in India, like FCV there are very few, okay, and few are on the trial too. So let's say if I look at 5 years, 10 years down, you not done after 5 years, definitely FCV will be more common. It has
And
very huge potential because your H2 gas like hydrogen and oxygen is commonly available in the air, right?
yeah,
And you need
okay.
to just use it and again release in the water, right? That would be more beneficial.
Yeah, clear.
Okay. So we will
Yeah.
see more deeper into it, like one by one, what is there into it. Like for BEV, okay, the common components. There is electric motor, there is inverter, battery, control module, and drivetrain. So what drivetrain is your, let's say, transmission systems. Okay.
Drivetrain, okay.
Drivetrains is nothing but your transmission system. This transmission system, drivetrain, they are taking. Like there is a motor, there is a battery bank, like, and let's say when you are trying to charge your batteries, okay, there is an inverter in place within the vehicle who will convert, okay, your needs like from the battery to your charging point to battery, like charging portion, right?
Yeah.
It will do. Second, there is a control module will be placed here itself between your motor to battery, and it will take care of to maintain the voltage criteria of the motor requires and what battery it has.
Yeah. So changing
The
what's the
DC-DC converter, you can say.
converter. So controlling the speed by frequency of the AC power.
Yes,
Okay.
yes.
Okay.
So, and external electricity is showing here to get the charge rate. Okay. So
Okay,
working
this is
principle, how it is, will let's say working power is converted from your DC battery to AC for your electric motor. Okay.
yeah.
Look at this DC to AC. Initial
Yeah. So,
devices were DC to AC. Okay. The
yeah.
accelerator pedal sends a signal to, let's say, controller, which adjusts the vehicle speed by charging the frequency of the AC power from the inverters to the motor. The motor connects and turns the wheels to cog, right?
Yeah.
And then when the brakes are pressed or electric car is decelerating, like we are pressing the brake, but vehicle is moving, right, because of momentum. And with that, we are taking a regenerative energy and we are charging the battery again.
Yeah.
Okay.
Clear.
Becomes an alternator and produce the power which sends back to the battery.
Yeah. Yeah. Clear.
There have been examples like Volkswagen e-Golf, Tesla, your Model 3, then Chevrolet Bolt, right? Nissan Leaf. There has been many more models. The Kia Soul, right? Mitsubishi IV, Tesla X also is there. Toyota RAV4. These are the things.
Yeah.
What happens with the plug-in battery electric vehicle? If I look at the component level understanding, there is electric motor, there is engine, inverter, battery, fuel tank, control module, and then battery charger.
Okay.
Right. So if onboard model is there, like the battery charger is depend if your vehicle is having onboard charger or not. Okay. Now, what is mean by onboard charger? That we will discuss in the upcoming chapters. We have a detailed understanding about it.
Okay. Clear.
Okay. So, how it's functioning? Let's say here we will read this first, so we'll get the understanding of the same. Like PHEV typically start off with the electric mode, as I said, right? It will just start with electric, operate on electricity until the battery gets packed is depleted, right? Some models shift to hybrid mode when they reach on highway. The crushing speed generally 60-70 miles per hour. Once the battery is empty, the engine takes over, and then while vehicle operates as a conventional or you can say the non-plug-in vehicle. Correct? Initially operates on the battery, and then later on the fuel tank will take care of everything. Like ICE engine will take.
Yeah, clear.
The examples are Porsche, Chevrolet Volt, right? Then there is a Ford C-Max Energy, Mercedes S550E, BMW Y8, BMW X5, right? There are many Cooper again. And there is Fiat 500E, Hyundai is also there.
Yeah, clear.
Yeah. Third vehicle, your hybrid electric vehicle. If you look at the component level, engine, electric motor, battery pack with controller and inverter, fuel tank and control modules. It has a fuel tank that supplies the gas to the engine like the regular car. It also has a set of batteries that run on the electric motor. Both the engines and electric motors can turn the transmission at the same time that run an electric motor. Okay. Both the engine and electric motor can turn the transmission at the same time. Means we can power the vehicle from both the engines at the same time.
Yeah, okay.
That is feasible in this HEV hybrid one. That's why it is called as a hybrid. So with the two different sort of technologies, you can power your vehicle at the same time.
Okay, great. Yeah.
There is a kind of synchronization happening within the vehicle.
So when you say it's you can start at the same times, I mean, is there a two starting point for each system or one starting point based on priority?
Based upon the priority.
Okay, clear.
But if as soon as, let's say, you are moving on the road and there is a you are traveling on a hilly area, right?
Yeah.
You feel that your motor is won't capable to take that much torque as required for the driving on the hilly areas, right? Then you can, let's say, power from your ICE engine too. Like both engines are working and you can move from that position to the higher altitude.
Yeah, clear.
Yeah. And the
Yeah, clear.
examples are like here, all are hybrid one. Your Honda Civic hybrid model, Toyota Camry, right? Honda Civic, like Toyota Pyrus, right? Those are only hybrid vehicles are there, but this is very, very costly item. And
Yeah.
very few people are buying to think to buy this because in normal scenario, there both the engines won't be used, correct? Only one
Yes.
can okay to travel,
Yeah, it's backup. Yeah.
right?
Yeah, clear.
There is a fuel cell electric vehicles. The working principle of fuel cell electric car is different as compared to that of the plug-in hybrid vehicle. This type of electric cars is because of FCV generates the electricity required to run the vehicle on the vehicle itself. I have not described this part because it's a topic itself to run through. How the fuel cell is working, you can search, right?
Yeah.
How it
Sure, I
is
will.
generating, you can look around.
Yeah.
Only
Sure.
thing is you can keep the mind like FCVs, there is a model, such kind of model, whereas from the hydrogen, there is electricity is getting generated. And that electricity we are using to charge the batteries and then powering the vehicles.
Okay.
Okay.
Clear.
There is a tank of hydrogen. The component wise, there is electric motor, there is a fuel cell stacks, hydrogen storage tank, battery with the converter, and control.
Okay, fuel cell stack. Okay. Okay, I will search for it. Okay. Yeah.
Examples you can check Toyota Mirai also, Hyundai Tucson, right? Then reverse sample Rasa, Honda Clarity, okay, and there is Hyundai Nexo too.
Okay, clear.
Okay. These are the four category of the vehicles available in nearby you. I'm pretty sure you just need to, let's say, understand more about it, and let's say from here onwards we are dealing with the battery electric vehicle. BEV is our part of journey. Okay.
Yeah, clear.
So we are going to understand more and more now about battery electric vehicle.
Yes.
Whereas component wise, within the vehicle, there is a battery, there is a motor, there is a transmission system, and there is a charger to charge that battery.
Yeah, on the level of vehicle itself. Okay.
Right? There is an option like there is an onboard charger or offboard charger. We will discuss that part.
Okay. Okay.
Okay. Do you have any query till now? Whatever we run through.
No, principle is quite easy. It's fine.
Okay.
Yeah.
All right. Now there has been few terminologies which we are mostly, let's say, whenever I'm saying something, might be I would say EV rather than saying electric vehicle, right?
Yes.
So those terminology will just run through. On the vehicle side, electric vehicle side, we will say let's EV. BEV stands for the battery electric vehicles. HEV is your hybrid electric vehicle. PHEV stands for plug-in hybrid electric vehicle. FCV is the fuel cell electric vehicle. BMS, whenever I'm saying, is the
management system. Yeah.
Battery management system. KWH, when I say it's a unit of energy, right?
Yeah.
Kilowatt hour. Then KW stands for the power. measurement, right?
Yes, yes.
Kilowatt.
Power
Then
is
SOC is a state of charge, right?
state of a charge. Okay.
State of charge, SOC. Now, let's say when you are looking at your cell phone, right? Obviously, you have, I mean, everywhere it's a smartphones right now, correct? So within the
Yes.
smartphone, if you observe your battery percentage, it is showing something 80%, 10%, 100%, right?
Yeah.
That percentage of the battery it is stated by your phone is nothing but the SOC, state of charge.
Okay. SOC.
Okay.
Okay.
SOC in technical terms for the battery, whenever we are dealing with, we will say SOC, state of charge.
Yeah, clear.
Then SOH, state of health. Okay. Like on the
State of
day
what?
first, state of health, which is again a analyzing parameter for the battery. Let's say a phone you buy it, and on the first day you are using that, right? The battery which you are using is a very new, right? And the health of the battery is 100%, correct?
Okay. After a
But
while, it will be.
after 5 years, does your health of the battery would be 100%? No,
No, no.
it
Sure,
is
no.
obviously depleted, right? And that depleted potential, that depleted health is measured in terms of state of health. It is measured in terms of percentage. Like on the first day, it's 100. After 2 years, what is this? What is the SOH?
It will be
Right?
less, of course, yeah.
It will reduce something. Let's say it's a 0.8, 0.7, 0.5, 0.6, right? Anything it can be.
Yeah, sure.
So we will see that part too. But in terminologist perspective, SOH and SOC is most common words which are using. Okay. And if I look at the electric vehicle mileage part, how people are calculating that?
Kilometer per state of charging?
Yes.
Bro.
Kilometer per SOC. Like in 1% of the reduction in the battery, how much kilometer your vehicle can travel?
Again.
Yeah. In 1% of state of charge of your battery, how much kilometer of your vehicle can travel? Like your battery,
I mean, so if you
SOC
charge
was
it,
your battery SOC, let's say you are located at a position A and your battery SOC is 100%. Okay. Now you have started your vehicle and you are moving from A to B. And let's say your percentage is reduced to 100 to 99.
yeah, okay.
Now you dropped your 1% of the battery.
Yes.
And how much kilometer you traveled within that 1%? That is mostly measured as a mileage for the vehicle. Similar way, what we are calculating for our IC engines, gasoline engines.
Yeah, so for 100 kilometers traveling distance, for instance, if the state of charging 100%, I will travel for 100% for 100 kilometers. If less at 1%, this considers kilometers per SOC, right?
Yes, 1 kilometer per SOC. Then it will be your what I can say, the mileage would be 1 kilometer per SOC.
Yeah, get your point. So this is a reduction in kilometers associated with the state of charging.
Yes. So there is a choice, like you can deal with the SOC or you can calculate with respect to KWH also.
Yeah. Okay.
Because SOC is not equal to your KWH. Okay.
Yeah, sure. It's depend on battery
Sizing,
performance.
capacity, right?
Yeah.
So let's say you have a 1000 kilowatt hour battery, but its maximum SOC only 100%.
Okay. Get your
right.
point.
Even if you are, let's say, 700 kilowatt hour battery, your maximum SOC is 100%.
Yeah. Yeah.
Correct?
Clear. Yeah, clear.
So these are the two terms which EV industry is practicing, like calculating the mileage. In gasoline, we are calculating like kilometer per liter, right? 1 liter of consumption, how many kilometers your vehicle is giving you.
Yeah, clear.
Right, in the gasoline, but in EVs, it is stated in the form of kilometer per SOC or kilometer per kWh.
Okay, kilometer per kWh. Okay, clear.
And charger side, people are saying, let's say EVSE. What does it mean? Electric vehicle supply equipment.
Electric vehicle supply equipment.
Ah.
This trigger which part exactly? You mean?
This triggers charger.
So the plug
So
in chargers itself.
yes, so you can say a charger itself, in other words, is called as the EVSE.
So the means the power supply.
In generic term, it is people are called, we are a EVSE supplier. What it means? It means they are a charger supplier.
So you mean the charger itself?
Charger it's
Okay.
electric vehicle supply equipment.
Okay.
So what is they are supplying? They are supplying the power. Correct?
Okay, clear.
So EVSE mostly deals with the charger.
Yeah.
And some people are also calling as a charger itself. But calling a charger is not a good habit. Like charger can be your cell phone charger, charger can be your torch charger, right? So fan charger, any charger. So the common name is, like, the smaller applications you can treat as a charger, but for the larger one, you can need to very specific upon the words.
Yeah, so the quality is electric vehicle supply equipment is the light terminology compared with the charger terminology itself, right?
Right.
Okay. Yeah, then DC/AC, fast DC is fine.
Okay. This is, I think, you should be aware with direct current, alternate current, and the common words. Then fast DC, people are saying the fast DC, what it means, like people are tapping to, this is again part of a DC charger, okay? Fast DC means people are saying a DC charger, they are, in general, they are talking about the fast DC. It's a slow DC, it's a fast DC, right? But what is fast DC, what is a slow DC, we will see in the upcoming sessions. There is a very good, let's say, examples, and you can easily find what is the lacuna in the industry.
Okay, clear.
Yeah. Then there is a slow charger.
Yeah.
Okay. Might be you heard this name, the slow charger, fast charger, or maybe fast DC, right?
Yeah. So actually, I think mostly it's about AC charger, maybe for a long time, and the capacity depend on.
Then there is a C rate. What it means, we will see in more detail in the upcoming slide, but C rate means it's your charging discharging rate at which you are giving the power from your battery to load, or from power source to charging your battery. Like that rate at which your battery is getting charged or discharged, that rate is treated as a C rate, basically. Okay. C rate is the rate at which battery is getting charged or discharged, that defines the value of C rate. Then AMP stands with your ampere, right? Unit of current.
Yeah, ampere is an ampere hour. Yeah, volt. Yeah, it's fine.
Yeah, these are the fine. Now the gun part.
Yeah, single or double, I remember. So gun itself for the charger itself, right?
Yes, the charger connector. Basically, people are saying like the connector with cable attached to the charger. People are saying the gun. Charging gun. Okay. Some people are saying charging gun, also people are saying gun itself when they are speaking in the EV ecosystem, right? So they are dealing with the, let's say, a charging gun instead of charging gun. People might be saying on the field, like take a gun and connect to the vehicle, right?
Yes, clear.
And gun itself, a combination of your connector and the cable associated with it, and these two things are attached to your offboard charger on the ground.
Yeah, clear.
Okay.
Yeah, clear.
So these are the terminologies where we will be going to look into in upcoming, let's say, sessions and understanding.
Yeah, clear.
All right. Do you have any query till? We will start your chapter 2, whereas types of EV chargers. Okay?
Yes.
And we will see, let's say, there is again 8 subpoints: electric vehicle charging technology and the charging equipments, basic charging block diagrams, the difference between slow charger and fast charger.
Yeah.
Okay.
Okay. Yeah.
These 3 points we will take today.
Yes.
Okay.
Great. Yes.
So slow charger, fast charger. There is interesting thing. You will be surprised that you have misunderstanding.
Really?
Yes. Across the globe, there is a misconception in the market that there is a slow charger and there is a fast charger.
I think it's more related to the battery itself.
Yes, it is actually not related to single device. It's a process itself.
Yeah, the source and the battery.
But the people are saying the charger is fast and slow. That won't be basically. I'll explain you on that slide. Okay.
Okay,
That will be.
let me guess if I'm let me guess again. I mean, the fast charger I'm expecting it should be if we have DC source and the car itself will of course it's DC battery. So this consider fast charger because DC to DC it's direct. There is no time conversion. There is no loss. I don't know. I'm just assuming.
Okay. Okay. So.
And the slow charger maybe if we have AC source, you still need something to convert this AC to DC, and then fill up your battery for an instant. So yeah, I feel that, but I don't know if I'm right or not. Let's see.
Wait for slide 3. You will clear with the thoughts. Okay.
Okay. I'm just
keep this confusion in your mind.
Yeah.
Everyone is having the same, okay, not about you, okay. Wherever I delivered these sessions and I observed that the people are like quite moving with the what are the false truths shared in the market, okay. And people are stick to that statement itself. It is a fast charger, it is a slow charger. Practically, it is not. Practically, it is something different.
Let's see.
But it's what I can say, the propaganda placed by the sales team, and the team is from the global organizations too.
Yeah,
they are sharing this because this is the selling point. Like comparison, if you do the comparison with like say the product 1, product 2, product 3, they are saying their charger is a slow charger, our charger is a fast charger. You will get the vehicle charge in the 2 hours from my device, and that charger will consume let's say 2.5 hours or maybe 3 hours to get it full charge. And people are saying that, oh, 2 hours is good for me, I'll buy that. And it is propaganda prepared by the sales team of the organizations. On a technical terms, it's purely different.
Yeah, clear.
Okay, well, we will see. Keep that interest.
Yeah, let's see.
Okay.
Okay.
Look at the slide. Just read it. I'll share those topics. I'm just having some water.
Yeah. Yeah. Okay. Then wait. Just wait for 2 minutes. Okay. Yeah, I think I understood. Yeah. It's clear, Vishnu, I think.
Clear?
Yeah, I think it's clear. It's mainly about 2 parts. The personal charger, which is a standalone one, and the public charger itself. I think the range is small for the standalone charger.
So in the standalone, basically, people are saying some people are saying it's a standalone, and some people are saying it's a personal charger. Mostly, this charger is given by the vehicle supplier itself. Wherever if you go to the market and buy some four-wheeler or two-wheelers, electric one, okay, this manufacturer will give this devices. And
Yeah.
that is a standalone charger, or you can say the small kind of adapter you can get with the vehicles, you can charge your vehicle.
Okay,
Yeah.
so it's like the connector and adapter for
Yes, it's
yeah,
a
for
kind of
car.
connectors for, and this is very specific towards the like two-wheelers, three-wheelers. And nowadays there is a charger coming for four-wheeler also. Like adapters are coming for four-wheelers also.
Again,
Uh,
Vishnu, I cannot hear this word. To what?
like let's
When you
say,
say,
can you hear me?
I can hear, but I mean, when you say for 2W, 3W, what
Two
does it mean,
W,
bro?
two-wheeler, like two-wheeler vehicles, four-wheeler vehicles,
Oh, okay, wheeler, okay, wheel,
wheeler,
okay.
okay,
Yeah,
wheels.
yeah,
W stand for the
yeah,
wheel.
yeah, clear.
So for two-wheelers or three-wheelers, industry is giving that sort of adapters. Okay, you can call it as a personal charger or the standalone charger. You can say anything. There is
Yeah,
just a top of three pin. You just need to put into the socket and you can start your charging. Right.
yeah, clear.
Nowadays, the four-wheeler also getting this sort of charger.
Yeah,
Okay, the cars and all, they will also get this sort of chargers. But if you do the charging from these devices, it will take a huge time, like 4 hours, 8 hours of duration to get the full
yeah,
charge of the vehicle.
okay, clear.
Okay, and there is a second option. Whenever you are, let's say, trying to travel from the city to city, right, one city to another one,
Yeah,
then you have option to connect with the public charging model.
yeah, three
Now,
options. Mm.
yes, now again, there is a three options you have. Either you can do the slow charging or you can do the fast charging to your vehicle, correct? And then bulk
Yes,
part. So I'll go one by one. Slow charging stations, yes, yes.
yeah,
Okay, if I don't know, but in India, the terminology when there is a government tenders is releasing, they are released with the terminology of SCS. Okay, and they are
yes,
and then in abbreviation they are stating slow charging stations. Okay, but common word is SCS and FCS, fast
yeah,
charging
okay.
stations. Okay,
Yeah, clear. Yeah.
now where we are putting this slow charging station?
It's mainly in maybe in home or
Mostly
in
in the homes, right? But it is also part of public stations too.
yeah, sure.
Right. Even you can put your parking, and let's say your neighborhood can come to your park and park their charge their car, right?
Yeah,
That
during
is
the night.
also possible. Or even let's say if you stay in the, let's say, multi-story buildings, there has been multiple flats, correct?
Yeah,
And within the parking, the common parking is there. There is multiple chargers or shared chargers, right? That
yeah,
can be also a slow chargers for your within the, let's say, the housing societies and all.
yeah. During the night, everyone can. Yeah,
Right? Everyone
yeah.
can, even a personal charger can afford this, or single person can afford this for their home,
Okay.
right? What it includes, the charger. When I'm saying a charger means what? What sort of feature it has?
It's just a plug and the inverter or converter. It depends on
Inverter and converter just to charge the compatible, as per the compatibility of the battery, it must
yes.
be charge your battery. That's the thing, right? But in
Yeah.
addition to this, when you are putting this charger in public domain, there must be a billing part integrated to it.
Yes.
It
So
is
to
mandatory one
yeah, for payment. Yes.
for
Okay.
payment and billing part, because on the standalone, your personal you will get it, right?
Yeah.
But on the public charging, every session must get recorded, every session must get billed, every session must get a proper receipt of getting the payment,
Yeah. This is
right?
clear.
And
Yeah.
this is required, and then only you can say this particular charger is public charger.
Okay, I get
If
your
there
point.
is no billing, there is no, let's say, payment option, then you can't put that charger into public places.
Okay, clear.
Okay. Now there is again a segregation that slow chargers and then fast chargers. This is again, I would say, like in general, okay, people are treating, the mindset is this, like AC charger, like the power coming out from this device in the form of AC, it means AC charger. Okay.
Yeah, yeah. It means the car
And then,
itself have somehow inverted.
right,
Sorry, converter, right?
converter, your
Yeah.
rectifier basically,
Yes, yes.
AC to DC converter, right?
Yes, yes.
Inverter stands with the in other part like DC to AC, but rectifier stands to your AC to DC.
Yeah, okay.
So when people are saying it's a AC charger, means your this box, your device will give the output in the form of AC, right?
Yes.
Then only you can say it's a AC charger. And a DC charger stands with the device which is powering to your vehicle that will give you the energy or the power in the form of DC power, right? That
Yes.
charger you can say it's a DC charger. Now FCS means, let's say, the fast charging, it can enable to your vehicle. Okay, how it will do the fast charging, that we will see. But the normal, you can say, let's say it's a fast charger. Okay,
But it can give both AC and DC?
no, this will be your
DC.
DC. But
Because
let's say fast charger can be AC, can be DC.
okay. So fast
Okay,
charger doesn't mean it's a DC. Maybe it's
right.
AC.
It may be AC.
Okay. This is important. Okay.
Okay. Fast charger, slow charger, this is a different category. AC charger, DC charger. So your AC charger can be slow charger, AC charger can be fast charger.
Okay.
In terms
So,
of DC as well. DC can be fast, DC can be slow.
okay, clear.
Okay.
Yeah, clear.
In the application areas in the public domain, like these are the public chargers. The application area is here. If you look at, if you have integration of billing and payment option, you can use this. You can put this into, let's say, societies, apartments, the common public parking areas, right, in the garage, and the common areas where like a mall parking and all everywhere, right? Those things. The fast charging options mostly targeted towards the larger parking lots, right? Where the what you can say, the public
commercial.
cars, the commercial aspects get fulfilled. The hotels, right? And the offices, like the charging depots itself, or maybe on highways, right?
Yeah, clear. Yeah.
Then you can go for this fast charger or the DC fast charger.
But they have payment system also, right?
Obviously, yes. So it's a mandatory part. The billing and payment is mandatory requirement for the charges. Without that, nobody will allow to put into the public.
Yeah. Sure.
And then bulk charging station like BCS. This is what I said initially, the battery swapping option. This is let's say a rack, right? From top, there is a cable coming. And within the rack, there is a boxes. If you see here,
for battery.
The battery. So you can just need to come here and then put your batteries in the one of the slot and get the charged battery out from the another slot and put into your vehicle and go out to the road, right? This sort of solution is called as a battery swapping solutions.
Yeah, clear.
And it is a bulk charger basically. Correct?
Yeah.
There has been 10 batteries in the single rack and rack is powering to that particular battery models.
Yeah, clear.
So there is again a feasibility condition that within that rack only the same battery you can, like the physical structure would be same, or maybe their characteristics would be same. Then only you can put into the vehicle, put into the rack, right?
Yeah, it's clear.
So it should be the same family of this. Then only you can, only you can come to the swapping station and then charge your batteries.
Okay. I think there will be safety issues here. It's the same.
Yes.
Yeah.
Yes.
Yeah. Because it's our behavior.
Exactly.
Okay.
Okay.
Yeah, clear.
Now, there is a
Okay.
different sort of technologies, okay, working on a different voltage levels.
Yes.
Yeah. Now, let's say our level 1, level 2, and level 3, there is a categorization.
Okay.
Then what stands with the level 1? The voltage range is single phase 120 volt. This is most commonly used in the USA.
Yeah, but when you say 120 volt level 1,
Hmm.
I cannot find level 1 240.
Sorry.
I mean here it's in specific that voltage is 120 volt at level 1. Can I find the 240 at level 1?
No, basically, this is a global categorization. Let's say in India, there is no level 1 exist. Okay. In India,
Okay.
there is level 2 itself because voltage we found as a single phase is 240 voltage.
Okay. Okay,
This
that's
is,
clear.
let's say, it's a global scenario. Like there is a categorization level 1, level 2, level 3 in the voltage
Yeah.
range.
Maybe this for US. Yeah, it's
Okay.
clear.
In US, the vehicles manufacturer are giving the adapters like this.
Yeah,
Okay.
from normal socket you can charge.
Yes, and they can get the charge from their home itself. So their home is supplied with 120 volt.
Okay, that's clear.
So might be they need this sort of adapter. Our homes are supplied with 240 volt AC. So we get this, and even this sort of adapters we have here also on the level 2.
So it's in level 2, it's the same. Means it's same socket or different?
That depends upon the structure of the like here, let's say level 2, the voltage should be 240, right? And
Yes,
then
but I mean in terms of
sustainability would be depending upon the socket.
yeah, I mean in terms of socket.
Yes, same. In terms of
Design.
socket, yes. In terms of design, it would be same, just little heavier one so that it can manage that current and voltage.
Okay, clear. Up to 80 ampere. Okay.
Yes. So basically, the range of operating level 2 is 12 to 80 amps.
Yeah.
In level 1, the voltage stands with the 120 volt single phase, and ampere stands with the 12 to 16 amps. Then charging load standing at 1.4 to 1.9 kilowatt.
Yeah, clear.
In level 2, the voltage is 240 volt, and then ampere coming from 12 ampere to 80 amp. But point is, if I deals with the, let's say, sockets, okay, socket not giving me more than a 64 ampere.
Yeah. Okay.
Okay, the manufacturing of the socket is max limit is 64. Then socket is not no more. And how I can reach with the this 80 amps? So there is like you need to put the MCB or MCCB, right? Within the network.
MCCB?
MCCB you need to put within the network, correct? And from that MCCB you need to get the power to this device.
No, I cannot understand this one. I mean, when you say 64 amp,
let's say this is the power line you have in your home.
Okay.
And this is the socket you prepared. I mean, you have option with it, right?
Okay.
In this, there is a limit of 16 amp. It is feasible, it is possible, it is okay. Correct?
Yeah.
This will work. Here also, there is option and there is a socket available.
Okay.
Okay. But limit of this socket is maximum 64. There is a socket available with the 5 ampere, socket available with the 10 amps, then 16 amps, right? Then 32 amps and then 64 amps. But if I want to, let's say, go for as max as possible, then there is 80, right? So if I have a charger of, let's say, who is operating a 3.3 kilowatt, okay, in general, in India, there is a small chargers coming.
Okay.
which is having the rating of 3.3 kilowatt.
3.3 kilowatt. Okay.
3.3 kilowatt. So if they are operating with this, like 240 volt AC, at the
Okay.
kilowatt rating of 3.3, their ampere is about to 16 ampere.
Okay.
Okay. If they are operating with a 16 ampere at a 240 volt, then I'll just use this sort of socket. Correct?
Correct.
Because it is available now within the 16 amp. Till
Okay.
64 I can go with, but let's say I want to install
See,
the charger rating of, let's say, 80 kilowatt.
80 amp, you mean?
I mean, yeah, 80 ampere, right?
Okay.
So what I can do, I need to put, let's say this is infra line, then I'll need to put the MCB, correct?
Okay.
Within the network, then there is a 4 line RYB neutral, correct?
When you say MCB, you mean panel
The
3-phase?
isolator, yes, panel itself. A
Panel
small
3-phase. Okay, so you need that's 3-phase. You can reach up to 8 amp.
3 phase supply.
Okay, that's clear. Yeah. That's it.
Yeah.
Clear.
Or maybe depending upon, let's say this is a single phase, so single phase, maybe phase and neutral.
Yeah, like breaker MCCBs
Yes.
in
Yes.
3-phase cables in connecting. Okay, that's clear.
Yes. Okay. Then you need to put this device.
Yeah, clear.
And then load they can operate with this, and then ampere with this. In the level 3, like you can put the large chargers, the heavy chargers, whose rating is more than, let's say.
But why is he mentioned single phase AC? I mean, in level 2, he should say single or 3-phase.
No, the point is, let's say this is 240 volt AC only.
Okay.
Here I stated something else. You just need to connect your single phase, like phase and neutral.
Okay.
Okay. MCB with the 2 pole MCB or MCCB. 2 pole. Like one
Okay.
is for phase and another is for neutral.
Yeah, so pole this for single phase.
2 for the single phase.
Yeah, but it's a bit weird because a charging load is 19 kilowatts. It's a quite high load which requires
Yes.
3-phase.
Yes. So that depends. That's what I think. So people are mostly going forward with the 6.6 kilowatt on the single phase.
Okay. Okay, clear. Yeah.
People are exactly okay with this. Maximum they are deals with the 32.
Okay, that's clear.
Okay. And for, let's say, larger devices, they are going forward with the 3-phase options.
Yeah. Yeah, this is a fast charging, maybe not fast
This is
charging.
like the device which I showed here is a fast charging one. Okay.
Yeah.
Or the DC charger. But here it can be AC also.
Yeah, of course. Yeah,
Yeah.
it's clear. Yeah.
And their ampere rating, let's say, close to 200. And you can go from the charging 50 kilowatt to 350 kilowatt charger.
Yeah, I used to see it a few days back. Yeah.
Now this is 350 in the market. The chargers are available with the 500 kilowatt also. A single charger with the 500 kilowatt.
Okay, clear.
This is currently operating in Japan. Okay.
Okay.
The charger name is Charge Demo.
Charge Demo?
Yes, Charge Demo.
CHADE.
Yes, CHADEMO.
Charge Demo is for 500 kilowatt.
It's a 500 kilowatt. Maximum it's rating at the 500 kilowatts.
Okay, that's clear. Yeah.
Yeah, now? Yeah.
Yeah, perfect.
Okay. You see the basic architecture of this. Okay.
Okay.
Like charger architecture now. We are looking forward for the internal architecture of the devices. Okay, and we focus to it.
Yeah. This within the charger itself, not in car.
Yes, it is in the charger part.
Yeah.
This is car.
Yes, clear.
So within the charger, what's happening? Like there is a AC supply comes through.
Yes, and the meter.
There
Yes.
is some protection and metering part on the AC side.
Yeah.
Then your device is converting from AC to DC, right? Or I mean, I said rectifier unit.
Yes.
And once it is converted in the form of DC, then there is a protection layer again. And then it will pass to the battery. Because why the protection is this? If anything happens with the battery, if there is a backfeed, then it will stop here itself.
Okay.
Right? Then your device will be on the safe line.
Yeah, I get your point. Okay.
So a charger is primarily AC to DC converter, or you can say the rectifier.
Okay.
You need the protection input as well as the metering part as well. Correct? So may have the current and voltage controllers over to this. Okay?
Some hidden part here. Yeah,
As your battery voltage changes during the charging, this part, your battery voltage changes during the charging, then this device, this rectifier will get notified that the voltage of the battery is getting changed, and it will manipulate the voltage of this output.
Yeah, clear.
Now this communication, how it is happening? Battery has a BMS.
Yeah.
Right?
Yes.
BMS, and this AC to DC converter, the rectifier unit, has its controller.
Yeah. Okay.
Okay. So these two devices are communicating with each other and deciding the charging strategy basically. At what voltage, at what current I need to put or the push.
Okay.
Okay. And this is done by the both.
Okay,
like
what is written on the left side here? A battery voltage changes during what? Charging? The charger voltage which I cannot read the full context. Okay.
Give me a minute, I'll correct it. Basically, it will get hide
Maybe.
into
You just need to understand this constant.
yeah, no worries. Let's start.
Yep. Yeah. Okay. Yeah, it's clear. Clear.
Clear now?
Yeah. Okay.
Basically, like here its own controller, and here it's a BMS.
Yeah.
These two items, these two controllers are communicating with each other.
Yes.
And they are deciding the charging strategy, like particular voltage, particular current, particular time.
Okay.
At this much voltage, this much current for this much time. And they are communicating every second or even some milliseconds too.
Okay.
And this is wired communication. How it is getting connected then? Because your vehicle is different. How it is wired? Your gun, like connector gun, right? Which you are plugging into the vehicle. That gun has power lines as well as communication lines.
Okay, maybe okay, I get your point.
That's and then once you connected this, it means you connected the both the things. Connected the power wiring, connected is the communication wiring also.
Okay.
And this communication enables your flow of electricity.
Okay. Can you go to the left content? May have current and voltage control. As battery voltage changes during the charging, charger voltage will change to keep constant current. You mean this is through the communication?
Yes.
Or constant voltage? Okay.
So let's say your batteries, the right now industry is practicing with the battery in the electric vehicles are the lithium-ion batteries, correct?
Yeah.
On the let's say battery is charging with the two modes. One is CC and another is CV. Constant current and constant voltage.
Okay.
At a first time, let's say you come to the charger and you started the charging. What happens? Always battery will start with the constant current. Why? Because battery, let's say if you observe, let's say battery is 0%. What is changing basically? The voltage is initially, let's say 52 volt or the 48 volt, right? And it reduced to 48 now. So 42 volt. Okay. It reduced to 42 volt. It means battery has a no charging scenario. Correct?
Yes. Okay.
So first battery will reach to its potential first. So they are just feeding the constant current like full of capacity and they are reaching to voltage, and then later on it will be CV mode, constant voltage mode. Once it reaches to the voltage level, the maximum voltage level, then you will be not getting chance to increase the voltage.
Yeah.
Like let's say battery is stated by the manufacturer, it's a 48 volt battery. When you are charging, does your voltage is increasing more than this?
Yeah. Clear.
No, right? It is not
No.
increasing. It is
Yes.
only 48. So it's always once it is reached to the voltage, it's CV mode activated.
So you mean two different voltage till you reach to the stability. You need constant current at beginning, and then reaching this. Yeah.
At the beginning, it's a CC, and after some time, it is CV.
Yes. Okay. It's clear.
Right? CV is usually the maximum voltage to which battery is to be reached. Once it is reached to
is there any other reason related to fabricating or manufacturing this to start with constant current? Or you mean
it's a firmware which is written into BMS basically.
Okay.
The reason is to maintain the battery health as good as possible.
Okay.
Yeah, and that is, let's say, we don't need to, like, there is no button or switch to toggle, like, I need to go with the CC and CV. No, it is the firmware within the BMS and it will take care of that.
Okay.
We just need to connect the device. That's the thing as a user we need to do.
Yeah, clear.
Everything is inside it's operating. I just explained because it's internally happening that should be aware of.
Yeah, it's clear.
Yeah.
Yeah.
Now, if you observe this part, the basic architecture like AC in, there is a protection devices, metering devices, there is a converter, there is again at the DC output protection, and then it is going to the battery.
When you say protection, you mean the protection circuit breaker and the metering?
Yes, kind of.
Okay.
The protection means your deals with the circuit breakers itself on the AC side.
Yeah. Okay.
Okay. What else do you feel like this is a very best diagram? What else do you feel to have on the chargers to make it more convenient for the user? What else you can add here within the charger? What do you think?
Within the charger, I think more monitoring system, or you mean okay. When you say adding, you mean in terms of technicality or user perspective?
User perspective.
I think somehow display to see what's going on.
Okay.
Ampere or kilowatt. I think you need to see this data on this display screen. I don't know.
Okay.
I don't know.
Okay, fine. Look at this. This is your base diagram on the earlier slide, right?
Yes.
What is get added? the payment gateway,
Yeah, clear.
the communication with the energy operator,
Okay,
and then there is a communication with the vehicle.
okay.
Okay.
Yeah, it's clear. Communication with energy operator.
What it means? It means like let's say charger is placed in the premises of the your office parking. Okay. So
Okay.
who is providing the energy there? The office itself.
So that means they can switch on off the charger from their own control room.
Like no, like for that operator, like who is powering your device? Like
You are talking about grid.
grid.
Okay.
So I'm talking about the grid, the communication with the energy operator. Mostly the grid persons, what they require, how much power their device is consuming, right? What is their energy billing and all, the meter billing, right?
Yeah.
But normally they are doing the monthly bill, monthly invoicing, correct? But let's say large fleet is there and there is a external power entity. There is open
Okay.
source. There is a solar power plant kept by somebody. They are powering your charging station, and that is open source or
Yeah.
open access power plant.
Yeah, clear.
Right? In that scenario, they must be aware to how much energy you are consuming.
Oh, okay, it's like monitoring all power consumption for load profile for the charging.
Yes,
It's
it's a summary part.
Oh, okay. I think this will be in the third part software.
Yes, it is inbuilt in the software. Just need to enable with the SCADA and it will work.
Okay, clear.
Yeah. And then payment gateway for the direct user or the consumer who is dealing with the charger to pay and get the energy to get it charged their vehicle.
Yeah, clear.
Yeah.
Yes.
So one part is communication with the grid, correct?
Yes.
Grid operator. Then your manage the power which is drawn from the grid and their billing is going to happen. It also have the payment gateway for the direct user, the consumer part. And then this part, the communication with the vehicle battery BMS. This is the wired communication which I said.
Clear.
Correct. The charger has standardized grid and vehicle power connectors. Obviously, this box is there is input is fixed sort of termination visibility, right? And output is fixed sort of gun connectors, radio, right?
Yeah.
And based upon that only you can connect the sort of vehicles to this.
Yeah, clear.
And may incorporate the communication along with the power.
Yeah, all in one. Okay, in the
One and one.
Okay. Clear.
Clear?
Yeah, clear.
Now
This just a quick one. This communication wire is like Cat6 something or what? So what type of this is what type of communication physical
mostly CAN bus protocol they are using, and the wires are like say 0.5 square mm copper wire annealed one, annealed with not annealed. Basically, these are the nickel plated wires, the copper nickel plated wires. But it's a part of gun itself. You want physically,
it's a part of it.
But the protocol they are following with the CAN bus protocol.
Okay, clear.
Okay. Now, similar the CAN bus, I don't think you are aware or not. You are might be aware with the Modbus, right? RS485 cable. Are you aware with this?
Can you repeat this one again? I cannot hear this one.
Modbus protocol, you are aware with?
Yeah, Modbus. Yes.
And CAN bus?
CAN bus, no.
No.
I did not hear it. This name, yeah.
Okay. In electric vehicles and the charger part, let's say communication between your charger and vehicle is going to happen with the CAN bus protocol.
CAN bus protocol.
Yeah.
Okay.
So in more deeper, you can read it, the comparative study also. what is the CAN bus and Modbus and their comparative points. Basically, that both are enables you the communication.
Yeah, the
In-
same function, but
Yes,
maybe.
but just to decoding option like the protocol, the encryption is in the different format. That's the part.
Okay, encryption in different format. Okay.
Okay.
Yes.
Now, here is the interesting topic.
Yep.
The difference between your slow charger and then fast.
Okay. Okay, it's about the charging and discharging.
So let's say it can be charging and then discharging. So if you look at here, it's a slow and it's a fast time mark.
Okay.
So
1 hour or less?
I would say, let's say there is no such a charger is treated as a fast or slow, in my opinion. Okay. It is always depending upon the scenario. Like there is a charger, okay, and there is a vehicle.
Yes.
Right?
Yes.
There is a vehicle. Now, these two entities getting charging, right? Or this is a source and this is a load, correct? And then there is a flow of current. Now, depending upon the requirement, this charger is feeding to your device. And that process itself defined as the slow charging process or the fast charging process. The process is either slow or fast, but this device won't be a slow or fast. You can't treat this device as a fast device and this device as a slow device. No. The process which they are connected with, which vehicle, and that process is defined as the slow process or the fast process. Now, what is the base fundamental of it? Like slow charger, when we are saying it's a slow, whenever the device is charging to the vehicle and that device takes 3 to 5 hours, okay, to charge your batteries.
Okay.
When your device is taking 3 to 4 hours to charge the batteries from, let's say, 0% to 100%.
Yeah, just consider slow. Okay, yes.
That will consider as a slow charger.
Okay.
Or slow charging process, rather.
Yeah, I think terminology is better to say slow process. Yes.
Right. And the process which is getting completed within 1 hour or less than that.
Yeah, this is fast. Okay. When we
that
say here,
process is fast charging process.
okay.
Now, when I'm saying the C rate, what is the fundamental? Initially, as I explained you, C rate means
Charge
the
and discharge.
rate at which your energy is getting in or out from the battery, right?
Yes.
That rate is defined as the C rate. Now, this rate is defined as a 0.2 C, 0.3 C at a 25 degree centigrade temperature in the slow charging.
Yeah, when we say 0.2 C to 0.3 C, you mean energy getting in and energy getting out?
So, both the scenarios. See, I'll explain you why both. Let's say this range is 0.2, or it may be 0.25, it may be 0.1. Okay.
Okay.
Or in general, less than 1 C.
1 C is
1 C is your
ideal.
fast charging.
Yes.
Less than 1 C. Whatever the C rate is there, which is less than 1 C, you can treat that charging, that event is a slow charging event. Now, what is it means? Like C rate is equal to, in calculation perspective, like 1 by your time.
Okay.
Okay. If this time takes 5 hours, your C rate is equal to 0.2
Okay. Yeah.
C.
Yeah. Okay.
Yeah. If let's
Your
say
time
this
is
time.
is 1 hour. That mean okay, fast charge. Okay. Yeah.
Okay. Now again, this is with respect to time. With respect to your battery capacity and charger rating, basically. Let's say your battery capacity is 100 kWh.
100 kWh. Okay.
kWh. And your charger rating is 100 kilowatt.
Yeah. Energy equal power multiplied by time.
So your power divided by energy.
Will give you the time. Yes.
This will give you 1 by H. Right? Kilowatt, this
Yes.
kilowatt get cancelled. So
Yes.
H is demand. So 1 by H.
Yes.
How many hours? It's 1 hour, let's say.
1 hour.
So it is 1C.
Okay.
So in understanding, let's say you wanted to charge battery capacity of 200 kilowatt hour, right? And you have a charger with you of 100 kilowatt.
Okay. So okay. I will let me just explain this one. So we have a charging battery capacity of 200 kilowatt hour. And my car charger is 100 kilowatt hour.
Kilowatt.
That means
charger is kilowatt.
Kilowatt, yes, kilowatt. So 100 divided by 200 will give you almost half. You mean 0.5 hour?
0.5 C. 1 by 2. 1 by 2, right?
Yes.
So like your power is, charger power is 100 kilowatt divided by 200 is the battery capacity, right?
Yeah.
So it's 1 by 2, right?
Yes.
So 1 divided by 2 is nothing but your 0.5 C.
Yes.
So it means your slow charger.
Yeah, it's so
and
you get one point.
Even if it is your DC charger.
Yeah, but when you say 100 kilowatts, you mean your charger in your car.
Sorry, say again.
The 200 kilowatt hour is the battery itself, right?
Right.
And the connector which carrying the power is 100 kilowatts, or the power delivered from the station.
No.
I need to understand.
Yes. We are dealing with the charging infrastructure, right?
Yes.
Does any vehicle coming to your charging infra and it is saying that I want to, let's say, release my energy? Is it the way? No. They are always coming for the charging.
Yes, of course.
Right? Only charging event is going to be recorded there. Discharging will be done on the road itself while it is powering to the motor.
Yeah, sure.
So in terms of discharging, we are not dealing with. But the terminology or the understanding would remain common in the both scenarios.
Yes, okay.
That depends upon, let's say, in vice versa, your battery is already 200, correct? And let's say the motor on the vehicle is having 100 kilowatt.
Okay.
Then what happens? Your vehicle's battery can power that motor for 2 hours continuously, right? If it operates on the full capacity.
Yeah.
Right? So it means it is giving you the energy in the rate of what C? 0.5 C only, even if it is a discharging.
I get your point.
Right? 0.5 C, because battery has a capacity of 200.
So
the power requirement is only 100.
Yeah, so the both component, energy or power, both is related to your car. Battery in terms of kilowatt hour, power in terms of the motor power itself.
Yes, in motor power in terms of when you are dealing with the discharging.
Yes, motor power dealing with discharging. And then you can assess what is the C rating, which is power divided by energy, which is equal 1 divided by H. Right? So C equal 1 by time divided by time.
Yes.
Okay, get your point.
So in other words, let's say you will get the clarity with this statement which I wrote here. Let's say your battery capacity is 5 kWh
Okay.
in the vehicle, okay?
Yeah.
And it is getting charged with a 1 kilowatt or 2 kilowatt charger. Battery needs 5 kilowatt hour. Your charger rating is 1 kilowatt or let's say 2 kilowatt. Then
Yeah, 2 by
whatever the
5.
operation is happening, what you can say, it's a slow charging.
You need to take the power divided by the kilowatt hour, which
So
is
2 by 5.
yeah, it will be 2, yes, which around it will be point.
It's 1 by 2.5.
Yeah, let me 2 by 5, which is 0.4. 0.4 equal 1 divided by h.
It's a 0.4 basically.
Yes, 0.4, yes.
0.4, right? Which is less than 1.
I mean 0.4 will be the C rating, right?
Yes, 0.4 C is the C rating.
Yeah, which is slow charging.
It is slow charging, correct?
Yeah,
And
yeah.
let's say your battery capacity is 1 kWh.
Yeah, 1 divided by 1 will be faster charging. Yeah, 1C.
And so now here, what I did, I changed this battery. Example, consider the scenario. Your charger is fixed at a one position, okay, which is having the rating of, let's say, 1 kilowatt itself. Okay, there is a charging station in your, let's say, office parking, and the charger rating is 1 kilowatt. When, or let's say, take an example for the 2 kilowatt. Okay, that would be easy to understand, like we did with this, right? 4.4C.
Okay.
So in your office parking, there is a charger placed. The rating of charger is kilowatt in terms of 2 kilowatt. And the vehicle is coming to that point, and vehicle battery capacity is battery capacity is 5 kilowatt hour.
Okay.
Right? And then whatever the charging scenario they did, that will happen with the slow charging, correct?
Yes.
So whatever the time it took, it will take roughly around 2 hours or maybe 2.5 hours to get it full charge. Correct. And let's say the charger itself, and then that vehicle charged fully in the 2.5 hours, and that moved to some other places.
Yes.
Now on the same parking, there is another vehicle reaches to get the charge, but that vehicle, the battery capacity is 1 kWh only, the small vehicle.
Yeah.
But your charger is still 2 kilowatt. The charger is not reducing its power, right? Charger will remain, device itself will remain at the 2 kilowatt rating. Now, charger itself on its position, vehicle is changing. Okay.
Yes.
And then this charging is happening with fast mode. Why? Because this allows, let's say, and battery is lesser. It will be 2 by 1.
So it's mainly depend on the battery is the battery kilowatt hour.
So not on a battery, it is on the both the devices.
Yeah, both devices, yes, but I mean for the same.
That operation is basically fast charging operation or the slow charging operation. It is not always like a charger is a fast or charger is a slow. No.
Yeah, I mean for the same charger, it could be slow, it could be fast. It depends on the battery kilowatt hour.
Yes, for the same charger.
Yeah, for the same charger. So we have 2 kilowatt here, 2 kilowatt here. The only difference is the capacity of battery changes from 5 to 1.
Yes.
The small car will charge it fast.
You are looking from the charger's perspective, right? That's why you are saying depending upon the battery. But let's say if you look at the vehicle's perspective, vehicle battery is itself 5 kilowatt hour. It is not changing, and you are changing the chargers. Like if you faced here 2 kilowatt charger, next station you reach and there is a 10 kilowatt charger. What you will do then?
Yeah. So it depends also on the kilowatt for the charger.
Then you will be saying that when I'm looking for the battery, it will be dependent upon the charger rating. No, basically it both are mutually equal. What I can say, the equal and preparing for that charging mode, right?
So it's 2 factor, not 1 factor.
Yes,
it's 2 factor.
it's always 2 factor.
Yeah.
It's always
From
your
battery
battery
point of
rating
view and
and your charger rating that mutually decide what sort of charging it requires.
yeah, that's
And,
clear.
and that is basically happening automatically. Manually, you need to do nothing.
Yeah, and just a quick one here. When we say power divided by energy equal 1 divided by H equal C, right?
Yes.
So this is the entire equation. The C
Yes.
rating equal power divided by E equal 1 divided by H. So if I need to calculate how many hours required to charge this car, depend on
So
the given kilowatt
in,
hour and the,
yes, in simple words, if anybody asks is, let's say, charging rate is 1C, will it be fast charging or slow charging? If it is more than 1C, it's always fast charging.
yeah, 1C mean 1 hour.
1C mean 1 hour.
Yeah, if I take 0.2C,
0.2C means 5 hours. 1 by
uh,
0.2,
1 divided by 0.2, right? It will be 5 hours, right?
it will be 5 hours, right?
Yeah, it's clear now. Yeah.
Let's say somebody is saying it's a 3C charging, 3 times. Then it will be how much time it will take?
3C?
3C.
3C mean 1 divided by H equal 3. That mean H equal what? Mean 20 minutes.
Yes, correct.
Yeah.
You got it
Yeah.
now.
Yeah. Yeah, it's clear now.
Okay.
Thank you.
So that's why
Yeah.
I stated that the charger power output and then battery size together determines the
Whether it's fast or slow. Okay, yeah. Okay.
this item
Yeah.
is determining the fast or slow charging, not a charger. Okay, it's a charging.
Yeah. Yes.
And the charger itself not a fast or slow.
Yeah, it depends on the two factors which we discussed.
It depends, always it depends.
Yeah. Okay, that's clear.
Okay? But in practical scenario, what happening? The rating of the DC chargers, the construction, right? The manufacturer is manufacturing, right? And they are manufacturing DC chargers with a higher rating.
Yeah. So the increase,
They are
it's a high
increasing the
rating
power.
in compare with the kilowatt for the
Yes,
battery.
in comparison with your AC ratings, the DC ratings of chargers are higher.
Yeah.
And that's why people are saying it's a fast DC chargers are fast chargers and AC chargers are slow chargers.
Yeah, but it's not the case here.
It's not the case, but practically, if AC chargers is, let's say AC charger is rating of 80 kilowatt and DC charger is rating of 50 kilowatt, then in that scenario, vehicle is, let's say 60 kilowatt, 60 kilowatt hour is the battery.
Yeah.
Then in that scenario, this is would be the slow charging if I go with the DC. Right?
I need to. Okay. Can you repeat this example again? I understand,
Let's say vehicle capacity is 60 kilowatt hour.
Okay.
You are having a DC 50 kilowatt charger.
Okay, 50 kilowatts, so 50 divided by 60.
It's a 50 divided by 60. How much it comes?
0.8 C.
0.8 something, right? 0.8 something. And here it's a AC charger of 80 kilowatt.
80.
So 50, 60 divided, 80 divided by 60.
Yes, 80 divided by 60, yes.
So it's
1
4 by 3, it's 1.33. Then it is fast charging. So can we treat the AC is always slow? No.
That's okay. That's a good point. No, okay, it's clear from me. Yeah. I like it.
It's always depending upon the scenario what we are dealing with. There is no such a charger like stamped as it's a slow charger and stamped as it's a fast charger.
Yeah, so
it's just a marketing agenda. So Steam has created this propaganda in the market and saying it our charger is fast charger. So let's stamp it. No.
Okay, that's it. It's a good point. Yeah, I understand that. Yeah, it's clear. Yeah.
All right. So you please go to, I mean, other resources and just read on it again and
Yeah.
get it more confused here itself. Okay.
Just
I'll
a quick
clear
one
you.
here. Yeah, just a quick one.
Okay.
When you say at 25-degree temperature, this is due to the, yeah, you mean this case, yani, if the temperature increase, the speed will be changed.
Basically,
Will be
yes,
less.
it's the STC condition,
Yeah.
standard temperature conditions. This is stated by the battery manufacturer. Okay. At a 25, it will perform like this. But
Okay.
and to maintain it, there is a what I can say, the HVAC is working around the battery. Okay. Heat ventilation and air conditioning devices, like
Yes.
air conditioning system is already equipped with the battery, and it is maintaining the same whatever they require, like 25 or 24 or 23, whatever they require, it will maintaining the same.
Yeah. Okay. So in case of there is a problem with the heat ventilation and air conditioning system, the temperature goes to 35 or 50. This will impact the C rating.
Basically, yes, it will impact the C rating. In that scenario, your battery will be immediately cut off from the charging.
So
Battery
okay.
has itself protection. It won't allow you to charge because it is already increased in the temperature.
Okay.
It
That's
is
clear.
too smart now.
Yeah.
But if you deal with the, let's say, lead acid batteries, there is no smart way. Okay. And that's why people are moving towards the lithium ion batteries.
Yeah, but most of the market now is lead acid,
Lithium
right?
ion, lithium ion, lithium ion.
Yeah, lithium ion. No, I mean lead acid, right? No.
No.
Lithium.
For
Lithium.
electric vehicle,
Lithium ion. Yes.
it's always lithium ion.
Yes.
The
So
small vehicles like a two-wheelers, few vehicles are operating on the lead acid, but even that will also vanish.
yeah. So what about this lead air?
Which one?
I hear about new battery will come to the market, not the lead ion. I mean the lithium ion. There is also lithium air or something like that.
No, there is aluminum air oxide, basically.
Oh, okay.
Okay, that will be coming. Let's say it will take a minimum 5 years to come to the global market.
Okay.
Aluminum oxide batteries, basically.
Okay.
And that is purely a different technology.
Okay. Yeah, that's clear. So just one more question here. When I need to see the C rating, I will find it on the nameplate of the car or
no.
it's in. Okay.
It is always nobody will define the C rating of that. The manufacturer will suggest you, like, you need to charge with the charger rating of, let's say, 2 kilowatt, 10 kilowatt, or whatever we are giving to you. In terms of that, they are giving you.
Because you cannot define the C rating because it's different to charge.
Yeah,
Okay.
correct. It's a very critical parameter of their.
They cannot fix that.
Exactly. It won't be fixed. They will say you the maximum kilowatt of the charger. Like, sir, you can charge your vehicle maximum of 50 kilowatt. Less than that, you can charge any rating. Okay.
Yeah.
But maximum would be 50 kilowatt, not more than that. Why they are saying? Because the BMS is getting code with that limit.
Yeah, that's clear.
The firmware of the BMS is getting coded with the limit. So, and in the let's say catalog of the vehicle also, they will mark like maximum charger rating is 25 kilowatt, 50 kilowatt, or maybe they will give you the model name, the charger model's name. Like this charger, this charger, this charger, you can get it and charge.
Okay. Yeah,
this technicalities nobody going to open in front of anyone.
Yeah, that's clear. Yeah, that is clear.
This is the execution done by the R&D team who is working at the back end.
Yeah, this is in the backstage.
Yes, it's always backstage.
Yeah, sure. That's clear. Yeah.
Yeah.
Yeah, that's clear. Today
all right.
Yeah, it's nice today.
So,
really.
You cleared that so-called thought.
No more confusion. It's okay.
No more confusion. Right. All right. So we will pause here. Okay. There is again in depth of topics which I expect that we need to be very keen about it. So before that, let's say for till now or very specific to the what I can say the charging scenarios. Okay. You can just explore yourself, get it more confused. Okay. I'm okay to discuss with you and make it clear with the thoughts.
Yeah.
Come
Sure,
up with the new
sure.
questions around these topics. We will discuss in the coming session, and again we will move to the remaining portion.
Yeah. Sure. Yeah.
All right. Anything else
Thank-
you have to ask?
That's clear. It's clear now. I
You
will,
know?
of course, once I say search, I will find something. So it's, but it's for now, it's clear.
All right. So we'll
Yeah.
stop here. Okay.
Yeah. Thank you, Vishnu. Thank
Yeah.
you.
Have a good day, Ismail.
You too.
Bye-bye.
You too. Bye bye.
And how
Okay.
it's let's say if I look at the accounting perspective, like the numbers, what is the unit, what is the energy, voltage, power, what they are dealing right now, right? So those points we are going to understand today.
Yes, get your boy.
So when I'm saying like in general, the right now the current trend in the market, if you look at across the globe, that is again similar for the globe. The two-wheelers, like the bikes and all, those are available in the form of electric vehicle I'm speaking. Those are available with a battery capacity of 1 to 3 kilowatt hour capacity. Okay. For the two-wheelers, for let's say e-rickshaws and the three-wheeler path, like e-rickshaw is kind of a small version of your electric auto. Okay. It has little lighter capacity. The battery range is 2.5 kilowatt hour to 5 kilowatt.
Yeah.
And for auto rickshaws, like having a heavy one with the three wheels, that is standing from 3 kilowatt hour to 6 kilowatt hour. And few are there with the about to 8 kilowatt hours too.
Yes.
And those, let's say, three-wheelers, but used for the commercial application for the good transfers, they are having the battery capacity up to 12 kilowatt hour in this three-wheelers part. And next to that, the four-wheelers standing the small cars, they are having the battery capacity of 15 kWh to 30 kWh. The large, what you can say in terms of large battery or in terms of long range vehicles, right? The four-wheelers, those can travel, let's say 300 kilometer, 250 kilometers in single charge. They are having the battery capacity about 30 kilowatt hour to 75 kilowatt hours. Okay. And for the bigger one like buses and trucks, those are operated in the cities. They are having the battery capacity of 100 kilowatt hour to 400 kilowatt hour. Right now, let's say many places, the vehicles like very specific domain for electric buses used by the authorities like municipal corporations,
public, yeah.
right? The public authorities. So the battery capacities for those buses are about to 300 kWh or 250 kWh. And few places they have been 350 kWh, not more than that. But they can extend up to let's say 500 kWh depending upon the requirement and all. Second part, if you deal with the large vehicles like trucks and earth moving vehicles, they are having the battery capacity of 600 to 1000 kilowatt hour.
1000 kilowatt hour.
1000 kilowatt hour. But for that 1000, nobody is going to go with the load on it. They are mostly doing with the 650 kilowatt hour the battery capacity on the vehicle, and remaining they are externally attaching based upon the requirement.
Okay. And,
because
and
the weight.
Do they have any cooling system for these batteries?
Obviously yes. And whenever let's say a vehicle manufacturer takes the battery from the battery supplier, the battery supplier is taking the design of the battery casing and all, everything. Okay. So that would be the part of your supplier. And basically he will be giving you the warranty on papers that it will run with this let's say vehicle speed and all, and then parameters of the standard conditions. And for particular years, he will warrant you against it, right? But the point is the design aspects, the technical aspect will be taken care by the battery supply.
Okay, clear.
And because that is a very keen process to have in the factory, and vehicle manufacturer won't take a risk on it.
Sure.
But because the domain of expertise would be completely different.
Yeah. Clear.
So in that scenario, let's say this is the market trend, okay, for let's say right from the two-wheelers to a larger vehicles, right,
Yeah.
trucks and all. But if you observe, their battery capacity is going to be varied, right, based
Yeah.
upon their energy requirement and how long they wanted to travel. Based upon that, the construction of the vehicle has been done. But if again I'm coming back to the point that if you have only 10 kilowatt charger in a place, right, which is standing, let's say your office areas or maybe a common parking, the charger is fixed rating of a 10 kilowatt, which is offboard charger, right?
Yeah.
And it would be treated as a fast charger for two-wheelers and three-wheelers, correct?
Yeah, because of power and
Because
energy. Yes.
it has a more power, it has a lesser energy requirement, right, to get it full.
Yeah.
But the same charger would be treated as a slow charger for your
Yeah, it's
four-wheelers
20.
and then bus part,
For
right from
four-wheelers,
here,
yes. Yeah,
this
four-wheelers,
part,
you mean a small car.
right? Small, from small car onwards to till buses and all, this the same charger would be treated as a slow charger,
Yeah, because it's 0.3C almost.
correct? So to pointing to the charger that it is a fast charger and slow charger, that is a quite a dumb idea, a dumb thought,
Okay, yeah, great.
right? So
Yeah.
basically, it's a process that defines the whether it's a fast charging or the slow charging.
Yeah.
And for similar approach, let's say if you deal with the 20 kilowatt charger, it would be treated as a fast charger for your two-wheelers, three-wheelers, and small four-wheelers too, right? For this portion, right? For 20 kilowatt, treated as a fast, but for the again large one, again slow. If even if you put the 50 kilowatt or let's say 100 kilowatt charger on the ground, that would be treated for the fast charger for the most of the application, like till this large car batteries, right? This should be treated as a fast charger, but again, for if the same charger deals with the bus, then it would be treated as a slow charger.
Yeah, that's clear. Clear.
Clear?
Yeah, clear. This point, I like it. Yeah.
So that's the difference standing with respect to the rating of the charger and the rating of the vehicle battery. So I have here with a data sheet of a single charger, which is a DC fast charger. Basically, it's a DC charger. Okay.
Yeah. It's not
So
fast or slow. It depends.
yes, but in general, people are, or the industry, wherever the industry people are communicating, they are mostly speaking this word. Okay, that's why I wrote, because otherwise, what happens? You need to be understand their language also, right?
Yeah,
Like
true.
the day in day out practices, whether it's wrong or right, that doesn't matter. It's a business.
Yeah. At least you know what's behind what is the
Right.
backstage. Yeah.
Right. So what is the backstage, you must be able to understand, and then whatever the front line you are playing, that is fine at all.
Yeah, that's clear.
So if I look at this is in your standalone DC off-board charger, right? So, or you can say the DC fast charger, which has three different guns, correct?
Yeah.
Have you seen this kind of charger?
I've seen a few days back, but double gun, not triple.
Two gun. Okay, fine. So most common, like this charger with the three guns, but you can again both the options are available. Two guns, three guns, both the options are available.
When he say, because I see the Bontograph as well, I like it also, but for this one, the power factor is quite high. It's 0.98. Efficiency is 94. So is this real number?
So this is the numbers at the input of power.
Yeah, I mean, is this real number? It's having
Yes,
power factor
it's
98?
it's real numbers.
Okay. Okay, when in output power, we have three output. You mean three gun.
Yes, 3 guns.
Okay, and for GPT, this is the outlet type. GPT 20 whatever. This is the output connector type.
Yes, correct.
Okay, when he say 200 amp, he
Hmm.
mean 200 amp DC
Yes.
or AC or AC.
Good question. Good question. See,
Yeah,
based upon the gun, and this is a DC charger,
yeah.
so it is a 200 amps DC only.
So in all,
No,
if you
no. Basically, see, if you look at this here, how it is divided in total, what is the rating of this device?
60 kilowatt,
160 kilowatt.
160.
160.
How I know that?
Where it is written?
It's not written in the upper section input power, but it's written in output rating. Output rating is 60 kilowatt.
60
At end,
kilowatt, 60
at it.
kilowatt, and 40 kilowatt.
You mean the total
Yes.
output from each gun?
Yes. So
120 plus 40 is
basically,
160. Yeah.
basically, 2 guns with a 60 kilowatt and 1 gun with a 40 kilowatt rating.
Okay. When he said 800 volt DC,
That
that
would be
mean,
common for all guns.
yeah. So now how I will read the 200 amp? I mean, how I will know if I am reading the data sheet? This is
Very
AC or
good.
DC?
Very
It's
good. Very
confused.
good. It's CC. 60,000 divided by 800. What is the value?
Yeah, it will come 60.
600 divided by 8. Do this. 600 divided by 8.
Will come 75. 600 by 800.
600 divided by 8.
Yeah, 60. No, 60,000
No.
divided by 800.
Similar to that, then 0 get cancelled. So 600 divided by 8 would be remain, right?
Yes. Then you mean, okay, they will give 75 amp.
75 amps, right?
Yes.
So this will be giving you the 75. This will be giving you the 75.
Okay. So this is, okay, but this is DC because you are dealing with volt DC.
That is fine.
Okay. So
So it's a
75.
parallel guns. Guns are always parallel at the output.
Yeah, but 75. You mean, okay, and 40 divided by 8. Let me
Whatever it
see.
is common.
It will come. Okay, so you mean total submission of output
Yes.
amp is
That would be
200
the
amp.
maximum
But
200,
this is
not more
DC.
than that. It's a
This is
DC.
DC. Yeah,
Yes.
clear. Okay.
Okay. And now again, like here, the connector is GBT. It might be possible that the 3 connectors should be from the different. Like one would be standing for the GBT, another would be, let's say, chat demo, and third would be the CCS.
Yeah.
Okay,
Okay.
that isn't possible. That is completely possible activities on ground, and it is there, and they are working. The advantage of this charger is like you can charge 3 different vehicles simultaneously.
Okay. So, but if you charge simultaneously, maximum 75, and whatever the
Obviously,
remaining.
yes. The total, this 200 would be divided based upon the requirement.
Yeah, but is there any difference in the delivered amp if the different battery are connected?
Yes, obviously. See, very good question. Let's say vehicle 1 is there, vehicle 2 is there, vehicle 3 is there. Vehicle 1 has a battery capacity of 75 kWh. Vehicle
Yes.
2 has, let's say, 30 kWh, and vehicle 3 has 80 kWh battery capacity, right?
Yeah.
And again, within that, vehicle 3, which is having the 80 kilowatt battery, but they wanted to charge from 80% to 100% only, right? So
Okay.
exactly how much they require? Only 20% of it, right? From 80 to 100, they reach, right?
Yes,
But
okay.
20% of 80 kilowatt hour, how much it is?
20% of of 80
16.
kilowatt hour?
16 kWh only,
16, yes.
right? So
Yes.
the vehicle 3 needs only 16 kWh,
Okay.
right? Vehicle, let's say vehicle 2, battery capacity of 40 kWh, but they want us to charge from, let's say, 30% to 100%. So consider the 30% value right from that. So 70, right? They wanted to 70% of energy.
Just a question here, Vishnu.
Ah.
When you said I have car and I need to charge for an instant 50%, that mean I will divide it the capacity of kilowatt hour divided by 2 because I need only 50%, right?
Yes.
So if I have 100 kilowatt hour vehicle and it's charged for 50%, that means I need 50 kilowatt hour.
Yes.
So I will take 60 kilowatt divided by 50 kilowatt hour. It will give me 1.2, which is around 1.2 C, which is right or what?
No. So if you checking, let's say in that context, so the
If I have
instantaneous,
60 kilowatt,
uh,
which is P divided by energy, which I needed, which is 50 kilowatt hour, right? It will give me 1.2. 1.2 it's supposed to be the C, as we said last time, right? If I have three car,
okay.
one need 50 kilowatt hour, and the second need 50 kilowatt hour, and the third need only 10 kilowatt hour. Yeah, so 50, 50, and 10. 50, 50, 50, and the 10.
Okay.
Yeah, so my question now is, how is a charger dealing with different rate in terms of distributing the ampere at the same times? If all are charging at same times,
Yes.
what is the ampere for each? Now, as per this situation.
Okay.
And each one, for how long a time it takes for charging from this unit? I just need to quick one.
Correct. See, so this is the common output bus bar where all three are connected.
Okay.
Okay. Here there is a converter unit of let's say, what is the rating? 160 kilowatt. Right?
Yeah.
This is the converter rating. Here it's a AC input from this to this.
Okay. Yes.
Here DC power is available.
Yeah, this is a DC, 160
This
kilowatt.
is DC, right?
Yes.
And vehicles are needed the DC because this is a DC fast charger.
Yeah.
Why it is calling it? Because it is giving the output of DC.
Yeah, and all connected parallel, right?
Yes, all connected parallelly.
Yeah, same volt. Okay.
Right. So voltage would be same for all of them. Now the point is, let's say this is 160, and who comes early based upon that, like first come first serve basis. Okay. Let's say vehicle one A, vehicle B, and vehicle C.
Okay.
Now vehicle A has battery of 70 kWh.
Okay.
Okay. Vehicle B has, let's say, 100 kWh.
Okay.
And vehicle C has only 30 kWh. But this vehicle wants to charge from, let's say, 20% to 100%, 20 to 100, right?
Okay.
Vehicle B wants to charge only for 80% to 100.
Okay.
Okay. And vehicle C wants to charge from the 50% to 100%.
Okay.
Okay. Now, if you do look at this, what is the energy requirement they have? This is only 35 units they needed.
Yeah, the difference between two, you mean?
Right? Yes. The multiplication you can do divide by 100 because this is a percentage, right?
Okay.
So this is 35 unit they needed. This might be need only 20 units.
20, yes.
And this might need, let's say, 20%. So
25 maybe.
20% to 80 or 24.
Yeah, okay.
Right? This needs 24 unit. This needs 20 unit. This needs 35 units.
Yeah, you mean unit kilowatt hour. Okay.
kWh value. I'm just
kWh.
fine. Okay.
Okay.
Now, Now, point is, what is the maximum limit of this? This is 10 kilowatt. This is 50 kilowatt. This is 50 kilowatt.
But this
In
is
terms
not the
of power,
reality because, and I'm just
yes,
before that.
it's a theoretical calculation. It's not reality. It's a
So
theoretical
I'm
calculation.
okay. So it's supposed to be 50-50 and 60, something like that, right?
Mostly the rating of this devices are like 50, 50 and 40. Okay. Even there is 60, 60 and 30. This combination is also available.
Yeah, 60 and 30, or
60,
60
60,
and 40,
30.
whatever the combination. Okay.
Wow, that depends. And even this is customizable.
Yeah, because it's
Okay.
written there, output rating is 60 and 40. I can use this one, right?
Yes, you can use this for the
Okay,
calculation.
let's use this one, please. Can just to understand. So
Fine,
it's
fine.
60 and
60,
40.
60 and 40. So this is
Yeah.
40, right?
Yes.
This is 60 and this is 60.
Okay, clear.
Now this gun can give you the power up to 40 kilowatt maximum, right? At a
Yes.
one time. And what is you needed?
24 kWh.
kWh.
So
Now
40 divided by 24.
your basically charger is capable to go with a 1C, right?
Yes.
So what was the formula initially? kWh divided by kilowatt or kilowatt divided by kWh?
It's kilowatt divided by kWh, right? Because E equal PT. So T equal energy divided by energy divided by power. Yes. Energy divided by power mean 24 divided by 40 will give 0.6. Yes, you're right. Am I right?
See, what was the formula to define? Just correct that. Please go
Okay.
and check. What was the formula? That
E
was
equal PT.
P divided by kWh.
Yes, equal 1 divided by H. I remember now. Okay. Equal
Right?
T.
So it's
Yeah.
a 40 divided by 24.
Yeah, this was okay. Okay, I'm confused now. Yeah, clear.
Clear?
So now
So it's a
it's
1 point something.
yeah,
So here
1.6.
charger is capable to power you with a 1C or more than that.
1.6 years.
Right? So charger is capable, but the point again, second point you need to check, does your battery is capable to charge with that rate or not? Because within the within the battery, there is a BMS, right? And
Yes.
it is coded with a certain limit factor on the C rate. If it is coded at, let's say, max limit would be 0.6 C, not more than that. Okay. Even if you connect here 60 kilowatt or 100 kilowatt, it will take only, let's say, 0.6 of 24.
You mean
About
the
to
limitation
15
of
kilowatt
C,
only.
the
15 kilowatt.
limitation of C rating, you mean?
Yes, limitation on the C rate. That is coded in the firmware of your BMS.
That mean even if I calculate it theoretically, still you need to have a look on the nameplate to know the maximum C rating.
Yes.
Okay, assume
And
the maximum C rating 0.6 here.
yes,
For this one.
yes. So it is just taking 15 kilowatt maximum power, right? Even if your charger is capable to give you the 40 or 100, whatever it is.
Just because of yes, limitation of and the cost
Battery.
of the
Yes.
okay.
So it's a limiting factor on your battery input gate. So it is saying, no, I can't handle that much power. Please give me only 15 kilowatt, then I will accept it.
Okay, but since we have a management system, so it's easily will not take the 40 kilowatt and it will take only 15 kilowatt.
Yes. So your BMS will, let's say, trigger an input to this device. I need only 15 kilowatts, not more than that. So this controller, which is inside this panel, will channelize only that much ampere to this gun because voltage is same.
Voltage is same. It's so 40 kilowatt for instance, but I don't need 40 kilowatt because the C rating of my vehicle is less than 40 kilowatt. I need 15 kilowatt for instance.
Correct.
Okay. So okay.
And same thing happen with the other tools as well, other guns as well.
So quick question here in between, because we have two mode now. The first mode is first in, first out. Okay, and the second mode is all charging at the same times. So what is the idea behind the mode if my
So
C rating is
basically,
limited?
see, when I'm saying first in, first out means, let's say scenario one, there has been 3 guns, but only one is engaged.
Yes.
Okay, and the rest 2 is on a standby. So in that scenario, your single gun can give the output of maximum rating of this device. Whatever it is, like here, it's a 200 amp, right? So
Yeah, but
whenever you select this guns, so this gun is capable to give 200 ampere current if your vehicle is capable to accept that. That is condition.
that's great. Okay.
Okay. So this is what it's playing around when I'm saying first in, first out, or the first come, first services, right? And
Yeah.
then let's say a second person comes in, then definitely he wanted to start the charging for this, then whatever he needed, then that much value would be reduced from this initial one. Correct?
Okay.
Then 2 would be like equal powers, equalized power, and that will be taken care by the controller which is inside this box.
That's clear.
Clear?
Yeah, but the question here, if my charger is if I have limitation in the C rating for the battery, for the purpose of fabrication or whatever the reason behind with the manufacturers. So having 2 mode of charging, first in, first out, or charging at the same time, it doesn't matter because the C rating, yeah,
Correct.
because the C rating is a key.
Correct.
Yeah. Okay. Okay.
C rating is a key to deal with the scenario.
Yeah. If I have the battery with C rating that can take all amp from charging, okay, that's good for first in, first out, because you can utilize all power, all amp, and that's fast. But
correct.
Okay, that's clear now from me.
So
Yeah,
that's why the manufacturers are suggesting the charger rating. Sir, you go to the market and purchase this rating of the charger, which is good fit to our vehicle.
Okay, that's
right,
clear.
and they are defining you with respect to the particular voltage and the current limit. Mostly they are saying you in terms of maximum would be 24 amps, maximum would be 200 amps, maximum would be like 100 amps, or maybe 80 amps, 60 amps, right? They are mentioning this value with respect to the voltage, like 650 volt, 1500 volt, 800 volt DC, like that.
Yeah. Oh.
Because they are aware what is coded into that DMS firmware.
Because I found that on site they have different DC outputs. I was confused, but now it's clear. But my just I don't want to have disturbance your ideas or thoughts in the sequence of this lecture. But just a quick question here is the input power. What I'm dealing with? I'm dealing with the kilowatts of DC, or I'm dealing with the. So if I need to.
No, this is your AC input to this charger. Like this, look at this, 3-phase AC.
Yeah, clear. But I mean, based on what I will decide, it's the cable cross section or for the input power.
For input power, based upon the charger rating, basically the input rating of this device.
So like, I should consider.
See, like the manufacturer will give this data sheet to you. Okay.
Yes.
And you know the rating of this device. What is that? It's a kilo in terms of kilowatt. You know, like let's say this is 60, 60, 40. So this is 140, 160 kilowatt. Correct?
Yes. DC.
DC 160. Right?
Okay.
DC 160. Now.
Okay.
In terms of current, sorry, in terms of voltage, you are clear here.
Yes.
415.
Yes.
Whenever you are selecting the cables, you can directly go with this 160 DC. Okay. Or because either or you're having like some buffer in the cable selections, like your degradation factors you are considering, right?
Yeah.
So even let's say manufacturer is saying it's just 160 kilowatt, and internally after losses of what I can say, that is AC to DC rectifier unit, right?
Yes.
So after considering the losses of that device, this is capable to give you 160 kilowatt. You can consider like this is an efficiency of
94.
94, right?
94.
So
Yes.
160 divided by 94%, like 6% more, you can consider and calculate your
Yeah.
AC cables.
It will be more around 170 kilowatts for me.
Yes. But point is, even if you select 160, that will be also fine, because there is a very rare chance that your charger would be
Yeah,
used
diverse.
at a full capacity.
Yeah.
That would be
But
very, very, very rare chance.
but my question is little bit يعني, I'm talking about DC output. DC output. So
PC output, okay.
should I consider my calculation based on DC output?
No. So your calculation, you are preparing for AC side or DC side?
I'm talking about the input power as AC.
If you are, let's say, trying to do the calculations for your AC power, you can consider the rating of the device. Like here it's a 160, so you can consider this value as it is for the calculation.
Okay.
This device is rated as, let's say, 160, so you can refer 160 kilowatt power would be maximum power for from that device, and you can consider as it is for your AC side calculations too.
Okay, that's clear.
Consider this is as a load of 160 kilowatt.
Yeah. Okay, that's clear.
Right?
Yeah,
And
the
then based on
environment.
your
Yeah.
voltage range,
Yeah.
handle.
Clear. Mm.
Fine.
Okay. Yeah. Clear.
So on the input side, here is 5 wire systems. On the DC, then the manufacturer states you their ambient conditions and all, right? The environmental condition, what they have with respect to the user interface and then control, protections, and communication part. Look at here. The charger and vehicle communication is happening through CAN communication, as I mentioned earlier, right? There is a CAN bus protocol. And charger and CMS. Like CMS is charger management system. Okay.
Okay.
We will see in detail what is it and how it works. We will see in upcoming sessions. So charger and CMS is using the protocol of OCPP. Have you heard this word?
Open. Yeah, I heard about it. Open point, charger point.
Open charge point protocol, right? So that we'll discuss in depth in upcoming sessions. What is it and how it is going to be used. So, but focus here like the communication between charger and vehicle. Communication between your charger and vehicle happening through CAN bus, and communication between your charger and CMS and maybe user, that is been followed with the OCPP protocol with the communication mode of Ethernet or Wi-Fi or any other option you can write Modbus and all to get that data.
Okay, so between charger and the vehicle, CAN communication mean charger and vehicle. Okay, between a charger and CMS for car management system.
No, this is charging management system.
Okay.
Like this is a you can say the SCADA placed on the ground.
Okay.
Within the charging station, like a area, let's say 1,000 square feet area, and there has been 4 to 5 chargers has been placed, right? So all those 4-5 chargers has been communicated to single device.
Okay.
And that device is giving data to one of the display where your supervisor can observe and then do the operations of those devices.
Okay, that's clear.
Clear?
Yeah.
All right. Oh, here is one more interesting point to understand.
Yeah.
This is the graph which states what happens when you are doing the fast charging and the slow charging.
Yeah.
And this is the graph for a single battery chemistry. Okay, this is the laboratory report basically. When you have, let's say, a single chemistry, when I'm saying, let's say, lithium ferrous phosphate as a lithium ion part, okay, and that chemistry is used in your batteries, for example, and that will, let's say, allow you to charge up to 2.6 C rate, right, at a maximum C rate for this. Okay, and then how the behavior of the battery is now. If you start charging process with the 2.6 C rate or 1 C or 0.5 C or 0.2 C. Okay, what is happening? That we will see, because this is really necessary to understand and to judge against the battery behaviors.
Can you just have an example on this graph so I can understand?
Yes, I'll share. Let's say there is a car whose battery capacity is 100 kWh. Okay, for an example. And the battery manufacturer told you that, sir, you can charge your vehicle from 2.6 C rate. Okay. 2.6 C. Okay. That much capacity the battery has, and battery can handle, let's say, 2.6 times higher power, right? So it means your battery capacity is 100 kilowatt hour. So you can charge this battery from 260 kilowatt power, kilowatt charger, right?
Yeah.
Correct?
Yes.
So with that kilowatt you can charge, or even if you try to let's say lesser than that, it is okay. That would be the maximum limit. 260 kilowatt rating of the charger would be the maximum limit. Not more than that you can go with, right? Below that you can charge any rating. And then you out from that, let's say the showroom, and then you started your charging of the vehicle. And you just wanted to try for what happens with the 2.6 C or maybe 260 kilowatt charger you connected to vehicle and started the charging. And your charging started from, let's say, 10 C, 10% to let's say 95% of the charging. Okay.
Yeah.
Your battery initially was on a 10%, and now you wanted to charge it for up to 95%. Correct?
Okay.
This is the scenario at a charger rating of 260 kilowatt.
Okay.
So what will be going to happen, considering that battery is capable to handle that much power, right? So battery will start the charging, and it will start from this point. Look at this blue graph, like 0. Okay, or maybe from here you are starting.
Yeah.
Okay, so here starting, and then it immediately shoots. So first, always it is starting with a constant current. Okay, CC mode, and then it will be, once it reaches to the voltage, it will go for the constant voltage mode. So let's say from here it is started the charging till it reaches to 57% only. Okay. And how much it reached? 57%. It's done with the CC. Your voltage, the cell voltage is reached to the maximum limit, which is 4.2.
Okay.
And then there is a no choice that you can't increase the current.
Okay, so it's from 57, it will start to be a constant voltage.
Yes, from here it will be start as a constant voltage, and now the game is here. Like the interesting thing, once you reach to the higher limit of your voltage of the battery, right, then you cannot push maximum current.
Okay.
Then from here your current value goes down, and from here your value, your time is more, until this is very short time to get it up to charge till 57. So that's why some manufacturers are saying like our vehicle is getting charged in 60 up to 60% in 10 minutes. Have you heard
15%, yeah.
this kind of
No,
what I can say, the
says,
salesperson has been trending this part.
okay. You mean
This is the business point. Like people are saying, my vehicle can getting charged in 10 minutes. It will be charged up to 50%.
okay, I'm confused a little bit here. I don't know why.
Confused? Okay, I'll clear you.
Mm.
How much it reached? 57%.
57%. This is a
260 kilowatt charger.
This is a state of charging, right?
Yes, this is the state of charge, SOC.
Okay.
From which 260 kilowatt hour charger, right?
260 kilowatt hour.
Right? 260 kilowatt hour.
Okay.
From this charger, right? So only you took how many units? 57 units, let's say. Correct?
Yeah. Okay. Okay.
So your total battery capacity is 100, right? So you reach to 57, means 57 in ideal scenario,
Okay.
right? So 57 units you consume. So let's say if you are charging the vehicle with the 260 kilowatt charger, and it will be like get the full vehicle. So how much time it will take? 1 hour, right? In 1 hour, this charger can give you the 260 units, but you needed only 57 or the let's say 60 for calculation, right?
Mm. Mm.
So
Okay.
reaching to this point, reaching to this 57%, how much time you get or the required is only 15 minutes.
From where you get the time? You mean from calculation?
Calculation.
Okay.
How I reach to this 15 minutes? Look at this. Charger rating is 260 kilowatt.
Okay.
Right? So if I let's say consider the battery has a huge requirement in idle scenario. So this charger can deliver in 1 hour 260 minutes.
Yeah. You mean at 1C, is this equal 260 kilowatt?
So it means I'm saying battery has a huge requirement.
Okay.
Abundant requirement. So your charger can deliver 260 units in 1 hour.
Okay.
Right?
Yes.
So means 1 hour means 60 minutes.
Yes.
So it is giving you, let's say, 260 units.
Yeah. And we need 57.
So you need only 57. So how many minutes?
It's like 57 divided by 260. It's 21. You mean I mean 21 minutes.
No, see 60 multiplied by 57 divided by 260. 60 multiplied by 57 divided by 260. How much it comes?
57 divided by 260. It will come 13.15.
13 point something, right?
Yeah.
So I just roughly calculated 15 minutes.
You mean the 57 is a 57% from whatever the kWh you need. Like that?
Yes.
Okay. So 57 is percentage of energy from the battery itself.
Yes.
Okay. When we say at the vertical axis volt, so we have 3.2, 3.4.
This is the cell voltage.
Yeah, but I mean
cell
voltage.
Yes, cell voltage maximum would be 4.2 for lithium ion.
Okay. So the 800 is the
battery voltage.
Yeah. So, no, in previous data sheet, the 800 it's the combination of volt from all cells.
Yes. Correct.
Okay. So we have here one cell.
Yes.
Okay. starting charging from zero state of charging
Correct.
up to 57. Why it's in a specific 57? I mean, why
No,
we
no,
cannot go
this is the behavior of the
constant?
chemistry.
Okay, so it's like constant current up to 57.
So,
This is a standard.
so when you deal with the 2.6 C
Yes.
for this chemistry,
Yeah.
this will behave like this.
Okay. And
It
if
will
different
reach,
C.
yes, at a different C, it is behaving something different. Look at this. Like
Yeah.
for
So
2.6, it will reach in 13.5 minutes up to 57%, right?
yeah, it's
For
clear.
this, it is reaching 80%. But what is the C rate? This is 1 C. It
It's
will take a
less.
little
So
more time. It will take 1 hour, right?
okay, okay,
To reach this. Then if
okay,
you look at 0.5 C, it will reach the CC mode up to 90%. 0.2
okay.
C, this will reach up to 97% in a CC mode, constant current mode.
So the normally they are not giving the state of charge for me. They giving me the C only.
Yes.
Okay.
So basically, this is initially I said this is the behavior of your single cell with the same chemistry
Okay.
at a different C rate. They are testing and they are judging the how the behavior of the battery in the field.
Okay. So okay, I get your point. Yeah. So up to 57, the SOC and volt are increasing together.
Yes. So what do you
Then
understand
constant.
from here?
Hmm.
Like if you go with the lower C rate, it will be like take a more time to get the charge of the batteries, right?
Yeah.
But in terms of health of the battery, it will be helpful always to go with the low C rate charging.
Okay. Yeah. Okay. Get your point.
Okay. So that's why the manufacturer of the battery, or let's say your vehicle suppliers, they are suggesting you the rating of the charger, right? They know the rating of the battery and they are always suggesting you the charger rating whose C rate would be 0.5 C, not more than that.
Okay.
People are always saying go for 0.5 C. Why?
Can you? Okay.
Because they are tested this cell performance in the laboratory.
Yeah. So it's so the higher SOC, the lesser C,
Say again.
the higher SOC. I
Hmm.
mean, the relation between the C rating and the
No,
SOC.
no. SOC is a different. C rating is different.
Yeah. Okay.
So
Okay.
this is just a plot where you can map this performance.
Yeah. Can you go for this partial charge for vehicle with large battery? Just this example, quick. The one which written there on the left side. Partial charge for vehicle with yeah.
Yes, you just read it, so you will get again more understandings.
Yeah.
Let's say one C charge with 85% DOD. Now, what is mean by DOD? It's a depth of discharge.
Okay.
Okay. Now, what it means, like 85% of DOD to full the battery charge in about to 51 minutes.
Okay.
Somewhat more as a CC, like constant current charging will get over, but constant voltage charge will take a much longer time.
Okay.
2.5 C charging should be in 20 minutes.
2.5. Yeah.
But the figure shows the battery will charge up to only 57%.
Yeah.
And slow down, right? Later on. From here, it is slow down.
Yeah.
Charging characteristics is chemistry dependent.
Yeah.
This is your performance of single cell with the same chemistry at the different C rate, right?
Okay.
4C is possible with a higher cost LTO batteries. Like this is again a different sort of chemistry, okay?
Yeah. What is lithium?
Lithium titanate oxide.
Okay.
Okay, lithium titanate oxide. This is a different chemistry, and this chemistry will support up to 4C rating.
So the curve, okay. Curve will be different for this cell. Okay.
Yes. So this will be again 4C means you can charge your battery within the 15 minutes.
Okay.
So partial charge for the vehicle with the large batteries. For vehicle with the battery of 600 kilometer range, basically 200 kilometers chargeable in 15 minutes at a 1C, or maybe 10 minutes at a 1.5C.
Okay. That's clear.
How it comes?
For vehicle with battery of 600 kilometer range, okay, 200 kms, chargeable in 15 minutes at 1C. 1C, okay. At 1C,
This
okay, 1C.
1C is this graph.
The orange one, okay. 15 minutes. What? Kilometers, okay.
So basically, see, for cars and all, basically, the it is very standard and achieved target like a mileage. Okay, mileage of electric vehicle, as I given you in the first topic, right? How they are measuring, like kilometer divided by kWh, right?
Yes.
kWh. But the point is here, like they are saying 600 kilometers means the mileage is normally 1 kilometer per kilowatt hour. This is the mileage of normally four-wheelers and then electric buses. Okay. So you can see 600 kilometer means 600 kWh for rough understanding.
Yeah, so you mean 600 kilometers, 1 kilometers for 1 kilometers.
Yes.
1 kilo,
Yes.
1 kilowatt hour to 1 kilometers, okay?
Yes. For calculation.
Okay.
And that mileage is basically depend upon vehicle to vehicle. That varies.
Okay. The next one was 200 kilometers. Chargeable in 15 minutes at 1C. If I go to 1C,
Yes.
200 kilometers. But I don't have enough information to say it's 1C or not.
Nobody will going to share.
Yeah, but how can I verify this one? Because no,
Yes,
I mean
you can verify that.
Okay, I mean we don't have now the kilowatt hour. We don't have the kilowatt. So based on what we said, 200 kilometers is chargeable in 15 minutes.
See, just divide it with respect to the time. This is 600 kilometer range of the battery.
Okay.
This is 200 kilometers. So how much percentage it is? 30%?
Yeah.
33. 33.
Yeah.
Right?
33. Yes.
In 1 hour, you have how many minutes?
Okay, I mean like 60. Yes.
60.
Okay.
So this is about to 25. 15 minutes means 25%.
Okay.
Got it?
Yeah, I got it. Okay.
Roughly that is the thought for the calculation.
Yeah, at 1C, at 1.5C. Okay, I get your point. That means whenever we change the C, okay. Okay.
The time will reduce. C increase, your time reduce.
Yeah. Okay. That's clear.
So basically, our point to explain this graph is this is the laboratory report taken by your vehicle manufacturer from battery supplier.
Okay.
This is not openly shared with everyone.
Yeah, upon request, maybe they will share.
Yes, based upon even in that scenario, you need to purchase the batteries from them, right? Then only they will share. If you are purchasing the vehicle manufacturer never going to share this.
Yeah, because this is performance.
Yes, this is the performance. And then if you are, let's say, channelize this their performance of the vehicle, the competition will take care of that.
Yeah. Yeah.
Okay, and again, this is very specific for the single chemistry. Every chemistry has this graph that would be different.
Depend on battery, yes, battery type. Okay.
Battery to battery. Right?
Okay.
Understood?
Yeah, it's clear now. Yeah. Oh.
Now, what is this?
This is a process.
This is the process. Correct. For what?
DC and AC charging. Charger.
This is the schema for your AC chargers and the DC chargers. How they have been connected, what are the all systems internally they have, and how they are performing.
Yeah. Okay.
Yeah. So we'll see one by one, like we will see the AC charger first.
Okay. 2 kilowatt. Okay, 2 kilowatt to 20 kilowatt, single or three-phase AC supply. Okay. Level 1 and 2. Yeah, logic 1 and 2.
Yeah. Single phase or three-phase supply. AC chargers, mostly level 1 and level 2 deals. Okay.
Yeah.
So basically, when you say AC charger means the standalone charger giving the output of AC only, correct? This is on ground. Look at this, the output is AC, correct?
Yes.
What it has a fixed load capacity, right? There is some safety equipments. There is a metering and billing part if this is a public charger.
Okay.
Correct? And what it gives? Only AC power, the protected AC power, basically, right? There is a protection. So your charger, which is onboard charger. So this is the onboard charger.
Yes, on board. It's a built-in power converter. Okay.
Correct. It is built in your vehicle.
Yes.
Right? The charger which is within the vehicle, you can say that is a onboard charger.
Okay.
Now, what is internally the subcomponents within your onboard charger? So the first item is rectifier.
Yeah, from AC to DC.
Right? Okay. That takes an AC input and convert into DC.
Yes.
Then there is a DC-DC converter.
DC-DC converter?
Because when rectifier converts from AC to DC, that converted DC is not a constant. It is again variable DC power.
Variable DC power.
Okay. If you match with the voltage of the battery to get it charged, you need to convert that, right? Let's say your converter is converting from, let's say here, rectifier converted from 440 volt to, let's say 800 volt. But that 800 is never going to be exact 800.
Okay.
It is always like 801 or maybe 799, 798, something like that.
Okay.
So that conversion of 1 or 2 volt is must needed because it is connecting to the battery.
You mean to maintain the voltage?
Right. To maintain the voltage, there is a DC-DC converter, the small one again.
Yeah, it's somehow
it is a, let's say, connected part altogether. You can't separate that. Right? It's look like a common box, and you might not be able to differentiate like where is the rectifier and where is the DC-DC converter. What they are doing, they are placing these systems in a box and they are covering it with the enclosure. And for user, they are saying this is your charger, onboard charger. But internally, there has been these subcomponents placed, right?
Yeah, that's clear.
So once it is converted from DC-DC, that goes to your, here it is marked as a variable DC, right?
Yes.
Because that is converted based upon the battery voltage requirement while charging.
I mean, from DC to DC, we say that we are trying to maintain voltage.
We are trying to meet the battery demands, basically. If battery asks, I need 800, your DC-DC converter will supply 800. Battery demands, I need 792. Battery will supply, I mean, this charger will supply the 792, right?
Yeah. So it depends on the
battery demand,
voltage.
right? And within this also, like here, they are marked based upon the requirement. CCCB mode will be going to active, right?
Yeah.
And how it is communicating to this controller, like battery has their own monitoring system, like we called as a battery management system, BMS, correct?
Yeah.
BMS takes the inputs of the battery, and this is giving that data, that control inputs
To the
your
protection circuit and
power
controller.
controller, right?
Yeah.
And
logic.
your protection circuit.
But this protection mean it should be flexible with different batteries. So how this protection circuit adjusts their behavior based on battery?
See, this protection circuit is a common channelizing to this, like within the vehicle, right? If you are constructing the vehicle, you know at what battery capacity the vehicle is required, right? The battery capacity is finalized. Similar with the fuel tank, you are constructing for two-wheelers, let's say the fuel tank rating is 7 liters. For four-wheelers, it might be 20 liters, right?
Yeah.
So based upon that, like battery capacity is fixed, like 100 kWh, 200 kWh, 50 kWh. And then accordingly, the protection circuit is, you can finalize at what protection unit I do required. So these are basically the contactors. They are channelized based upon the BMS inputs. Whether
I understand that it is the behavior of protection circuit. It takes the feedback from BMS based on the battery voltage. So if my concern is, that means this protection circuit is flexible protection circuit.
Yes.
But what is the terminology flexible in protection? It's somehow it should be covered from risk, or I don't know, but what type of protection circuit exactly?
So this is you can say the rectifier. What type of protection circuit exactly? What do you require here? So I can hit that.
What I required here is this just a fuse or circuit breaker or?
Okay. I got your point. See, here there is a contactor and the fuse. Both the systems are there.
Yeah.
Okay. So most of the times contactor will operate. Okay. And very rare chance that fuse was blown.
Yeah, but okay, but feedback from BMS to protection circuit.
Yes, there is again what you can say, the a small PCB which can read the input and which will command to your contactor that you need to isolate now.
So it's like a smart, flexible system. It's not just fixed rating of protection.
No. It's, let's say, the electrical components are fixed one.
Okay, but this is a protection within the EV charger.
Within the EV, within the electric vehicle.
Okay. Within the yes.
This is within your that closed box.
Yeah. So this is a car.
Yes, this is the car. This is the car.
Okay. Okay, regardless if it's a car, I don't care much about protection. I know it's there, but I mean, okay, that's okay. Okay, but protection from the charger itself, which is a previous section. Okay,
yes,
it's not safety. Yeah.
Here, mostly your switch gears has been used.
Okay, so where I should make calculation from my end.
For see, internally also you don't need to think. Before this, if you are looking at, let's say, if I look at the integration perspective, like system designer, I really don't think so internal components. I thinking about what is input, what is the output. That's the thing.
Yeah, I get your point.
So for, let's say, if you are trying to design the charging station, you deal with this part only, not about this, not about this.
Yeah, that's clear.
You just need to, let's say, select the charger with respect to your EV rating. That's the thing.
Okay.
And you can select that based upon the data sheet. That's fine.
Okay. That's
It
clear.
is the internal system which I am trying to explain you so that you will be aware and then acknowledge the same.
Yeah, yeah. That's clear.
So
Yeah.
let's say while charger is connected to the vehicle, what is going on there, right? You must be at least aware so you can judgmental while taking the call on a field,
Yeah, yeah. Yeah, that's clear. Yeah.
right?
Yes, that's clear.
Yeah. Now,
Yeah. Now the
any
DC.
query with the AC part?
No. It's
All clear?
easy. Yeah, it's an easy one. Yeah.
No. All right. With the DC, see, uh,
Offboard. Yeah.
yes, this is offboard charger.
Okay.
This is your charger. What it has, the rating is in the form of AC, right?
Yeah.
There is a variable DC supply, means your this unit.
Yeah. So instead, it's a onboard in the charger itself.
So charge, all those conversion is going to happen on the ground itself, right?
Yeah.
Variable DC, and then there is a safety diagnostics, right? Interlocks, safety interlock is there.
Okay.
While you are connecting the gun with the charger, there is a safety interlock. Like gun should be mechanically locked within that socket.
Yeah.
Okay.
But
And
our car should applicable to deal with DC, right? As outlet.
yes,
Okay.
like let's say this is your charger and this is your car.
Okay.
Okay. So, and you are connecting to this. So it must be mechanically locked here during the charging.
Okay.
Okay. Whatever the conversion from AC to DC is going to be happen in the offboard charger. There is a metering and billing part in the offboard charger itself. And the variable DC, the controlled voltage and current is going to be hit in the your protection circuit.
Yeah.
Within the vehicle, right? Vehicle also has some protection units like the same, this unit.
But this different type of levels, this give limitation for flexibility on the road for charging. So if I'm only charging with DC and there is no level 3 DC charging on the road, that means I'm in trouble. I need level 1 and level 2, or there is somehow flexibility to charge if I'm on board and off board regardless of the charging station.
Yes. Regardless of charging levels, it is just onboard and offboard. It deals with that.
So the car itself, the vehicle itself can deal with both of them.
Yes, because the systems internally has been made with that standards so that it can cope up with irrespective of these levels.
Yeah, but if I have, for instance, if my car is required DC and I am charging from level 1 and level 2.
No, not possible.
Not possible, yes, because you don't see, yes,
There
because
is
the
no
component.
input port of AC here for your, like, let's say your car is having anything, like anything, right?
Yeah.
So your car is having a port of AC input, then you cannot connect the DC there.
Yeah, sure. Yeah. Okay.
And if there is a DC input, then you cannot connect the AC there.
Yeah, but the good thing is that most of these small cars are level 1 and 2 max.
So you can connect only this, not this.
Okay. But do we have a small car at DC charging at level 3? Only in big car, maybe buses.
No. See, in India we have both the options.
Oh, okay.
I have seen both the cars. Those can able to charge with the AC as well as DC.
Okay.
And even some cars are coming with the 2 ports. One is the AC input, another is the DC input. So whatever you have available with, you just need to connect that.
Okay.
Yeah, so this option is available in the cars now.
Okay, that's good.
So if you have AC, then connect to the AC port. So AC port is having internally onboard charger. This is there connected the same, right? And if you are directly deals with the DC, you can just connect to this and this will flow this diagram.
Yeah, it's clear. Yeah, clear.
So, and here the flow, rest of the flow, like from the protection circuit, CCCV mode, going to the battery, monitoring inputs are coming to your protection units, right? If there is hurdle and all, they need to trigger. And if not, then BMS will send the data input to this device. Now, point is how they are connected then, how this data is reaching to this, because this is two separate devices, right?
CMS maybe. Or, I mean, there is OCPP and there is CMS, right?
Yes, there is a CAN bus and there is a CMS.
Yeah, so I think this is the way they are using it to communicate
This
with
is
each other.
basically CAN bus.
Uh,
Okay. And if you remember, like in earlier slide, as I marked, this
it's not same. Okay,
this gun has power lines as well as
that's
communication lines.
okay.
And this is connecting to your vehicle, right? You are connecting this to vehicle. It means here, let's say this, something
And the
like
data.
one,
Oh,
two,
okay.
three, and there might be a communication pins as well. So
Yeah.
this pins has been connected to the vehicle side, and then flow of the data is going to be happen.
Okay, between the charger and the vehicle CAN communication. Okay.
Yes, charger and vehicle has a CAN communication.
Okay. And the where is the OCPP will come in picture here?
OCPP in earlier slide, if you remember, look at this.
Yeah, this is a protocol between a charger and the SIM and the
And OCPP deals with the what? Charger and CMS. Means when you have a multiple chargers on a ground and you wanted to monitor that, then there has been some rules, right? And regulations you need to follow.
Okay.
That rules and regulations has been marked in the OCPP and which is globally accepted.
Okay. So in global, if I need to monitor multiple charge in one network, I need OCPP
Yes.
protocol
Yes.
between a charger and CMS.
Yes, because see, if I give the freedom to the everyone, and they will finalize, let's say, different protocols to prepare their CMS, and there might be a chance to millions of the protocols then, right? Which won't be good. Let's say vehicle owner is coming to the charger, and then they might be, let's say, not compatible with the CMS. Then what is going to happen? He won't be able to charge, and that would be the problem. So
yeah, because
to make everyone on a common plane, there is a definite protocol called as your open charge point protocol. Like for the public charging, it is you can say mandatory one.
Okay.
For the public charging, it is mandatory part across the globe that your charger should be tested with the OCPP.
Yeah, but this means that it's using IP system, right?
Yes.
IP. But this is not accessible or applicable for hacking or.
No.
Okay.
So it is just protecting your data. It is availing the billing part. It is availing the metering part. It will
But
be
you
help
cannot.
you to analyze the administration systems and all.
But you cannot switch off the unit from this protocol.
Yes, you can do switch off.
Oh, but is there any risk of hacking here? If I have public
no risk of that. There is no risk because it's your choice. If you do, let's say, off that protocol, and if you have your own customized protocol, then your charger won't be a public charger. That would be the personal charger. Then you can do with anything with that. And yes, it will be function, like charging will going to be happen. No worries at all.
Yeah, that's clear.
Okay.
Yeah, clear.
All right. There is one more point, which is onboard and offboard charger. What it means.
Yeah. Yeah, that's clear. It's fixed at vehicle mean it's part of vehicle. Doesn't play communication role. This is not clear. Doesn't play communication role. Yes, because this is not clear. The second one doesn't.
Okay.
Wait.
This is onboard charger fixed on onboard charger means fixed on the vehicle, right?
Yeah, so there is no impact on the grid, you mean?
Yes, doesn't play
As
communication role means
Hmm,
it is not connected to your CMS.
okay.
Got it?
Yeah, that means it's in-house interaction.
In-house in the vehicle.
Ah, okay.
It is not sending any data to your CMS.
Yeah, but if I need to
No, there
get
is no
information,
choice.
no, just my concern. If I need to get information about the load profile for onboard charger, when you say onboard charger, it's part of vehicle, right?
Yes, it's a part of vehicle.
Vehicle
So,
or part of charging station.
no, part of vehicle.
Okay, part of vehicle mean I cannot get the data about the load profile for the entire year of
So
or
you
24 hours.
have, in second option, you have a metering system in your
Yes.
AC charger, right? So you can get load profile from that meter also.
Okay, so the load profile I can get from, yes, regardless of off or on board.
Yes. Load
Okay,
profile you
that's,
can catch from that, your local device.
yeah, but so what is the importance of saying doesn't play communication role? You
So
mean,
this is basically the data of BMS.
okay, BMS between the car and the unit and the charger.
Yes, yes. Within the
Charging it.
car, right? That is also communicating, right? And
Yes.
that data is very crucial to understand the behavior of the battery, right?
Yeah.
As well as the life of that. And that is not shared with the CMS.
Mm.
Okay, that
Okay,
would
that's
be
clear.
available within the vehicle only.
Yeah.
The charging
That's clear.
station owner cannot theft that data.
Yeah, get your point. Only power module available rectifier. Okay, that's clear. Add vehicle cost and unwantedly. Ah, you mean because it's increase the cost of
Yes,
the,
because
yeah,
it
of the
is
cars.
hanged
Additional
to your
circuit.
vehicle,
Yeah, yeah.
right?
Then
And
offboard, yes, that's clear. Offboard fixes a charging station. Yes, play communication between vehicle and the grid. So you can get information about the car behavior
yes, car
between
battery
the,
behavior, right?
yes. So, okay. Having both communication and bar module, yes, clear. Cost reduced because we don't have this board. Okay, that's clear.
Okay.
Yeah.
Now there has been some other points on onboard chargers. Stay with the your electric vehicle,
Yeah.
right? Dedicated to the vehicle, may be portable
Portable?
or non-portable.
Okay, so there is an option to
There
provide the
is an
onboard as
option,
portable. Yeah, okay.
yes, but mostly like for small vehicles, it is portable one.
Okay.
Okay. Sold with the vehicle and connected typically AC sockets charger. It has a plug point. For example, two-wheelers and three-wheeler chargers, which is operated on the level 1 and 2, prevalent in Europe and USA.
Ah,
They have like a onboard charger which is portable and onboard charger which is fixed to vehicle. Both the options are available. In India also, this type of chargers are available, and that is come up with the like small two-wheelers, then small three-wheelers. Okay,
mm.
it's an optional part.
Yeah, that's clear. Yeah.
And
And
see the advantage like having a portable option, like you have two vehicles and one charger, that is fine, right?
yeah,
You
that's
can
fine, but
manage.
yeah, but of course, additional cost will come if I have portable.
Yes, yes.
Yeah,
Then
but
in
it's
offboard
still,
chargers,
yeah,
sorry, you are saying something.
yeah. But I mean, even if it's portable, it's still less than the built-in onboard, right?
Yes, it is always better to inbuilt.
Yes. Okay. Okay.
In the offboard chargers, not with the vehicle, usually these are the DC chargers. Okay.
Okay.
In the normal practices, those are the DC chargers. People are
Yeah.
is always okay to buy the AC chargers, but not the DC, because DC chargers have a higher cost.
Yeah, that's clear.
The chargers with a rectifier installed in the public places, including offices or the homes, and the vehicle can directly plug into DC socket, right?
Yeah.
That you
Yeah.
can call as an offboard chargers.
Yeah, that's clear.
Okay.
Yeah.
So clear with the thought of
Yeah, but I
onboard and
just
offboard.
yeah, that's clear. But just a question come to my head that now
Please.
is if I if I have multiple car within same area, that mean if I need to check their impact on the grid since we open this topic here
Right.
in terms of communication and data, that mean I get the data of submission of all power delivered.
See, you have, let's say, 10 chargers you have in a single place, for example.
Yes.
Okay.
Yeah.
And those 10 are with the multiple combinations, the mixed one. Few are
Yes.
the DC, few are the AC, right?
Yeah.
And with the variable ratings.
Mm.
But for that, within the premises, based upon the capacity, if you have your own transformer, right?
Yes.
Then authority will cross check that your layout and all.
Yes, but
And then
I think, yes, I think, but as part of my work also is to study the power demand, the demand power for this 10 units. So shall I take the summation of 10 units, or
yes,
is this somehow a way to reduce the demand load based on behavior of usage? So if I
yes,
say,
you can. See, when you are putting in request to the authorities, there has been two options. One is connected load, right? And
yes,
another is sanction load.
yeah, demand
So,
load, yes,
right, demand load. We in India we call it as a sanction load, right?
okay,
So one is connected. So connected might be, let's say, 100, but the sanction would be 80, sanction would be 60, right?
yeah,
So that's your design and your call on the ground, what you wanted to go with. If you are pretty sure about like board, the load never exceeds, let's say, 60 kilowatt. Okay, you
yeah,
go for the approval of only 60 or 65. That's fair enough. You connect up to 100 kilowatt the connections, like the connected load, right?
yeah, yeah,
But in case if you exceed that limit and if your cables are not capable to trigger that, but you connected excess units there, might be
yeah.
cable is going to be burned,
Yes, but
or
yeah, that's clear. Yeah.
right, or
Mm.
might be if you selected the cables according to your connected load,
Mm.
then authority will penalize you because you are exceeding your limit.
That's true. Yes.
So, and see, it's a practices you need to follow on the ground. Similar approach, whatever you are following in other terms and conditions, other sort of projects.
Yes, but yeah, I got your point. But here is if I don't have only 10, if I have within one building, all are electric furnaces. Just assume. I know this
Yes,
is not
yes,
the case.
considering that, right?
If I assume, that mean I need very big substation. So for sure
Correct.
they have
You,
solution
hmm,
for tackling this issue. If I have 10 mega electric vehicle
hmm,
charging station, this 10
hmm,
mega I cannot count in my substation because this is massive construction.
yes.
So for sure they have in their software maybe how
So
to handle
that's
this
why,
10 mega.
see, that's why your OCPP helps to the grid authorities as well.
Okay.
Got it? The
You
CMS
mean,
and OCPP help you to the user as well as this authorities. They
yeah,
are able to locate how much chargers placed in which area, what is their rating, then does our system infra will capable to manage that load or not, then what we need to do, whether we should approve that the SLD or not. From that onwards, they are doing these calculations.
no, but yes, that's great. Yes, I believe that. But I mean, at the first stage of the project, I don't have any behavior data, and I have 10 mega of chargers. I need to connect to the network. This 10 mega, I don't have any previous behavior.
Okay.
I don't- and I don't, and this located in area which we don't know if what type of behavior will be after 1 year. So for sure, this 10 mega, I can manage for maybe the manufacturer will come for EV and say it. I can manage this 10 mega within the usage of 3 mega based on this methodology of first in, first out, for an instant. So we have 10 mega, but the manufacturer of EV said, okay, I can manage this 10 mega by using only 3 mega. Is that something on field like that, or I should count for 10 mega at diversity 60%?
No, basically the manufacturer won't come to that conclusion. Like you need to decide, like you are integrating the system on ground, correct?
Yes.
So you need to decide based upon the grid understandings in that locality. If there is a option to sustain 10 megawatt power,
Yes.
and let's say a battery of your multiple vehicles, uh, if possible to time shift and let's say manage from the 3 megawatt, that is your call. Like you're dividing the load according to the day.
Okay. So it's my decision. Okay.
It's your decision always.
Yeah. So if I coordinate with the authority and I tell them we will
Yes.
have a management plan
Yes.
for utilizing only
Correct.
3 mega, but we need the connection for 10 mega.
Exactly, but see the connection also you don't need it for the 10 mega. You can take the connection of 3 megawatt and
Okay.
you can manage your load based upon time. At the same time, it cannot exceed more than 3 megawatt.
Okay. I
Right?
get your
The
point.
constant load they are giving you 3 megawatt for 24 hours. So you can manage that.
Yeah, because when they are presenting one seminars for EV, I attend these seminars and they said that they were able to get supply for 3 mega or for 2 mega, while the original connected load of all EV charging station was 10 mega. So I was wondering and how they can manage this one, and it seems it's the same connection, but the behavior is different. So
Yes, the time shift is important.
Okay, that's clear now. Yeah, that's more clear. Okay.
Yeah.
Yeah, clear. Very good.
All right. Here we have some calculation sheet.
Yes.
Yeah, that would, let's say this is very, very common calculations parts. This we have calculated for 24 kilowatt hour battery capacity. Okay. For this battery. And this is the charger ratings. Okay. To charge this battery, this is your charger rating. How much time it requires to get it charged at the input of particular this at a maximum current and mode of the charging.
Mode of charging. Can you just?
So see, this is just divided into sort of numbers.
Okay.
Mode 1, 2, 3, 4. Like mode 4 is, you can say, the fast charging part. The higher charging.
Okay. So it's just the grid.
Just for the understanding.
Yeah, this is the order, the signal. Okay. So what we are talking about here is 24 kilowatt hour capacity of battery.
It's a battery.
Yeah. If I charge it from 2.3, I just need to calculate it with you.
Yes,
quickly.
please do calculate.
Yeah, so it's for 2.3 kilowatts. So 2.3 divided by 24. No, we are taking a power divided by
Kilowatt hour.
energy.
Yes,
Yeah.
yes. Do it. How much it comes?
Yeah, okay.
1 by 10 somewhere.
Yeah, I don't. So for it will. Oh, why? I mean, 2.3 multiplied by 10. 2,300 divided by 24,000, right? So it's a 0.09.
0.09, right?
Yes.
So it's a 0.09 C, correct?
Yes.
So how much time it requires to get it full charge?
It should be multiplied by the 60 minutes, right? Or I don't know. Wait, again. So power divided by 2.3 divided by 24, right? Am I right?
See, 0.01 C, right? So 0.09, right? So
I think
0.9,
summation 80%. What's that 80%?
it's the capacity. Like 24 into 80, you do this.
So I will
That is
use
an
this.
effective.
Yeah,
So it's a 20
okay,
somewhere.
now so it's like, okay, 19.2. Okay, 2.3 divided by 19.2. Now we have 0.11 into 60 minutes, 7.1. So it's like, why it's not coming 8 hours and 20 minutes? 2.3 divided by 24 multiplied by 80%.
How much it comes?
It comes 0.119.
0.119 C, right? That is a C
Yeah.
rate. Roughly, you can say that is 0.1 C.
0.12 C, yes.
12 C, right? 0.12 C, right?
Yes.
So
yes.
1 C means 60 minutes.
Yes. If I yes, 1 C is 60 minutes. So 0.1 C is 7.1. It will give 7.1.
7.1
or 7.2.
In reverse way, you do this calculation. 19 point, what it comes? 24 by 24 multiplied by 80%.
Okay.
How much it comes? 19 point.
It will give 19.2.
19.2 divided by 2.3. In reverse calculation.
Okay.
How
I
much
mean,
it
yeah,
comes?
my mistake now is always I'm taking power divided by, it's coming 8.3.
8.3, right?
Yeah.
So now 8 stands with your integer part, 0.3 multiplied with the 60. 0.3 multiplied with 60. How much it comes?
Yeah.
18.
18 minutes. Yeah.
18 minutes. So
yeah,
8 hours, 20 minutes, 8 hours, 18 minutes.
Yeah, so my mistake here is I'm taking the power divided by kilowatt hour. Is that my mistake?
No, both ways are fine. What you need to do there, like you got a C rate there. 0.12 is a C rate.
Yes.
Okay. And you need to find how much hour it will take to conclude this.
Yeah, yes, I get your point, but I mean, I don't want to take it in inverse way. I need to take it in normal way. Normal way, it will be power divided by energy, right?
Yes.
Power divided by energy 2.3 divided by energy, which is 24 multiplied by 80%. Why it's giving me different numbers? It's given 0.11 or 0.12. 0.12 C.
Yes, 0.12 C.
0.12 C. Yani, this is not logic. I don't know. I feel something wrong in my mind.
That is a C rate. C rate is always 1 by hour, 1 by time.
So you mean 1 divided by the answer?
Do one thing.
Yes, I know. Yes, I got it now. This is equal. This is equal. This is equal C. If you need time, you need to have 1 divided by this answer. It will give you 1.
Right.
8.3. Yeah, that's clear.
So if you do 1 by 0.12, then it will be somewhere 8 point something.
8.3, yes, 8.3. Now the 8.3 for each one equal 1 hour. So we have 8 hour. 0.3 is 0.3 from 1 hour. It's 20 minutes. Okay. Clear.
Got it? Similarly, for let's say if you calculate with the 3 kilowatt power, 3 kilowatt charger, for this battery or the same vehicle, it will take a 6.5 hours.
Okay, that's clear now. And with 100 kilowatt hour DC, it takes 15 minutes. Yeah, it seems logic. Which is the maximum amp you can get from this maximum amp you can get from the charger, right?
Yes.
Based on the situation. Okay. Okay.
Okay.
Clear.
This is the multiple scenarios for your same breaker.
Yeah, that's clear.
All right.
Yeah.
Okay. So should we continue? Should we stop here?
Yeah, it's up to you. And for me, it's fine, but it's okay. I think it's okay for today, if you like.
How long it goes? Because I'm not able to see the time here.
I think it's remaining
12:50. That's fine. We started by 10, right?
Yeah.
So because the next point is about the new topic. So we'll take it fresh.
Yeah. No problem.
Okay.
Yeah.
We'll take this with the fresh mind. So it will be again hitting to this interesting part like AC pile chargers, DC pile chargers.
Pile.
Yeah.
Okay.
What it means, the pile and all that we will see.
Okay, no problem. We'll see. No
And
problem.
within the, let's say, module 3, there might be, I think we have OCPP here itself. See.
Yeah.
So we will be discussing more details in this, and you will be pretty clear with the thoughts then.
Yeah, that's clear.
Whenever you have, let's say, feeling something not understood, raise the question, we will discuss and we'll close that.
Yeah, of course. Yeah, I like it. Okay. That's clear.
All right, then we will pause for today.
Thank you, Vishnu, for your effort.
Yeah.
Yeah, appreciate it.
Thank you.
Yeah. Thank you.
Have a great day. Bye-bye.
You too. Bye-bye.
Yeah.